A confirmation regarding the audio, please. If you're able to hear me out perfectly well, kindly confirm the same. Thank you. Human geography, Aditya, we will be starting in the portion of Indian geography. So that will be next week. That is when we will be touching upon the portions of human and economic. I hope that you are aware what comprises the portion of human geography and what is the portion under economic geography as well. Mandeep, how come tropical cyclone moves from west to east? That is purely because of the movement of the trade winds in certain cases. When we come to the next module, that is the portion of Indian monsoons, we will be analyzing how is it that the trade winds in themselves, they change their direction in between the various seasons, which drives the monsoonal winds to India. So that is the precise reason. As the trade winds, sometimes they change their direction from west to east. That is why these cyclones also experience a movement like that. Oceanography, we will start day after tomorrow, Sumit. Temperature inversion is always associated with radiation fog, Pranay, in most of the cases, yes. Okay. Hello, a very warm good evening to all of you, and welcome to Byju's Exam Prep IAS. Welcome to another session of geography, where today we shall be dealing with some of the important atmospheric phenomena which end up influencing the global atmospheric condition and global climatic conditions that we end up experiencing. So, in this particular portion, we are going to analyze the areas of El Nino southern oscillation or El Nino La Nina circulations that we observe. What are they? Why are they created? We will also take a look into Indian Ocean dipole, Madden-Julian oscillation, as well as the portion of jet streams before moving on into the area of Indian monsoon. So in the last session, we had initiated a discussion for Walker cycle and Walker circulation. And in the portion of Walker circulation, we had seen that under normal conditions, you have the trade winds which blow in general from east to west. And these trade winds, they are able to carry the surface water. That surface water, which is the warmest layer in the region of equator, that warmer water is carried over and dumped in the region of Western Pacific. That warm water tends to accumulate and creates a region where you have an accumulation of warmer water, that is a low pressure area. And that low pressure which is created in the region of Western Pacific is due to the accumulation of warm water region. On the other hand, as the surface water is being driven away, you have the subsurface water which is colder that rises to the surface. And that is where you have a comparative creation of a high pressure in this area, that is the eastern part of the Pacific coastline or the western portion of South American coastline. This initiates a circulation from the region of east to west, and this causes significant amount of rainfall in the region around Indonesia, Philippines, also in the region around Australia, northern and eastern Australia. They receive significant amount of rainfall due to these conditions. However, the Peruvian coastline, the Chilean coastline, these tend to remain dry during these conditions because of the high pressure created in that region. So that is something that we had looked at previously. That is, trade winds, they blow from a general direction of east to west, and then winds blowing over the vast expanse of Pacific, they gain a particular speed because there is no force of resistance, no force of opposition that they experience. As a direct consequence, these trade winds, they drag some amount of surface water along with them. All that surface water is dumped in the region of the Western Pacific. Now, these surface waters, they are generally warmer due to higher solar insolation, and they accumulate in the region of Western Pacific. There you have the creation of low pressure. In the eastern portion of Pacific, you have the creation of high pressure. and that initiates a circulation across the same latitude, which is very different from the circulations that we have seen in the case of pressure zones and the pressure belts and the permanent wind system as well. So because it is so different, that is why it is named as Walker circulation. Now, this Walker circulation does not only exist over the region of the Pacific. You will have this Walker circulation having its extension due to the low pressure and the high pressure centers. It will have its extensions in various other oceans as well. So, for example, if you take a look at the accumulation of warm water in the region of the Western Pacific, here you have the creation of a low pressure. This low pressure will be dragging or attracting winds from both these areas, right? Both from Indian as well as the Pacific Ocean. So there you will have the formation of very dense and very thick cumulonimbus clouds. So this is an area, this entire region will receive very heavy amount of rainfall. And this low pressure system that you find in the region of equatorial Pacific, sometimes given the conducive situation, they can travel all the way to the region of Bay of Bengal as well. And when a low pressure system is present in the region of Bay of Bengal, that is when we experience the formation of tropical cyclones in the region of Bay of Bengal as well. So that is how this low pressure system can lead to sometimes the development of tropical cyclones in Bay of Bengal by transferring the low pressure cells into the region of Bay of Bengal. However, if you take a look at the region of Arabian Sea, that is the Western Indian Ocean, due to this circulation, what is the impact going to be observed in the case of Arabian Sea and Western Indian Ocean, low pressure or high pressure? What do you think? Very good. Beautiful. So here you will experience a high pressure. So in this case, can a tropical cyclone get created in the region of Arabian Sea under these conditions? What do you think? Perfect. Absolutely not. So that is why these are the normal conditions. These are the conditions which are prevalent under normal situation. So conditions prevalent under normal circulations. Okay, the conditions which are prevalent under normal circulations, that is something which you will find to be predominant throughout most of the years in general. Okay, now when we are talking about the movement of the winds over the water system, over any water body, that brings into impact and phenomena the aspect of upwelling and downwelling as well. Now let us try to understand what do we mean by this upwelling and what is meant by when we see the mention of downwelling. So this is basically the movement of oceanic water, the vertical movement of oceanic water, which is caused due to the influence of the wind system in the coastal area. So this is vertical rise and fall of coastal waters. Why? Due to influence of the winds. Now, what are these? What do we mean when we say upwelling? What do we mean when we say downwelling? And why are they caused? So, in order to understand this, let us take a look at the very basic of this, the very basic portion. Suppose here you have a large water body in the form of an ocean, let's suppose, and both ends demarcate a kind of a continental landmass, let us suppose. Now in this case, If we have, this is the land and this is the sea. This is again the land. So here, if you observe the movement of winds in this direction, will it be considered onshore or offshore first of all? What is it that this wind will be considered as, onshore or offshore? What do you think? Perfect. This is offshore wind. It is moving away from the land. Now, these offshore winds, they will tend to drag the surface water along with them as they move over the water body. These will have a drag impact and the surface water will be taken away. Now, as the surface water is taken away, what will happen? Will you observe that water level in an area significantly lowers down? Will you observe that you have a depleted water body in that region, or will you observe the subsurface water to rise up and replace the depleted area? What do you think? What will happen in this case? Very good. Subsurface water will be exposed. So in this case, the subsurface water, which is present at greater depths, they will start to rise up, okay, and they will replace it. So here, subsurface water rises up to replace the depleted portion. So here, you observe an upward movement of water in this area. There's a kind of an upward movement. So that upward movement of water, that is what is referred to as upwelling. Okay? So that is what is referred to as upwelling. Okay? Raises, not rises. No, Raja, that is absolutely incorrect. It will be rises. What is the meaning of raise in English? Whatever is present, that in itself will get elevated in a way, or there's no movement. When you raise something, there's no movement. Rise is the movement. Rise is where you have an individual particle which moves. That is why rises is the correct usage of the term here. Okay, so that is what is referred to as upwelling. Now, this wind continues to move. This wind continues to move. Now, as this wind continues to move, we have seen in the case of Walker circulation as well, that it will be carrying the surface water along with it. It will be carrying the surface water along with it. Now, all this surface water, what will be the temperature of it? Will the temperature be higher? Will the temperature be lower? What do you think? What will be the temperature of this water which is being carried along by the winds? Will the temperature be higher? Absolutely yes. Because this is the topmost layer. Topmost layer is the most heated layer. So that is why as the topmost layer is being carried off, it is the warmer layer which is being carried off. That is when the lower regions which are considerably cooler, they will start exposing them to the surface, and then those also get heated up over a passage of time. They are also carried away. So whenever that water is being carried, the surface water, this is the warm water. This is the warmer water. Now here, as it approaches another coastline, what will happen to this warmer water which is being carried out? Will the warmer water tend to flood the coastline? Will the warmer water tend to slightly accumulate in this area? What do you think will happen? It will basically start accumulating ever so slightly here. Correct, Deepika. So it will start to accumulate ever so slightly here. When they accumulate, then owing to the pressure exerted from the top, these are then pushed down, because furthermore, continuously more water is being brought about. So that will exert a pressure on the existent accumulation. So the accumulated water is then pushed or is forced down. And this significantly submerges. And this is where you experience that the warmer water which had accumulated on the surface, that warmer water is now being pushed down. This is a feature which we refer to as downwelling. Okay, so let us recap the entire process. When we have a surrounding water body near a land area, whenever you will have offshore winds which will come into play, those offshore winds as they are moving about, so suppose this is the water body, as the offshore winds are moving on top of this, they will carry some amount of surface water due to the frictional drag. They will be able to carry some amount of that surface water. That surface water will always be heated up because it is experiencing maximum amount of solar insolation. Now, as that surface water is being carried away, that creates a scenario where the lower levels which are present in the lower regions, water which is present in the lower regions, they will start to rise up and they will start to replace the vacancy which is created. So that replacement is done. And that is where, if you consider the sea surface temperature in this area, as compared to the normal conditions, wherever we find that upwelling is happening, what will be the impact of sea surface temperature? Will the sea surface temperature in this area, will you have cold water or will you have warm water where upwelling has happened? Very good. Here you have, because the water from the lower depth is rising up, that is why you will find the presence of cold water. Okay. And this wind is able to carry this warmer water along the surface, maybe for 100 kilometers, maybe for 1,000 kilometers as well. Eventually, when it hits the region of the coastline, that is when this water will accumulate. And this water is continuously coming from behind. The wind is consistently dragging the surface water. All of that is getting accumulated. Meanwhile, more surface water is being dragged along. So under that influence, this will start to descend. This is something which is forced down. So here you have the accumulation of that warm water, which is eventually pushed down, which is eventually forced down. So what will be the temperature conditions in this area? Will the temperature be higher or will the temperature be lower in this area? What do you think? Very good. Here you will have higher temperature. Higher temperature. So that is the impact created by the winds in terms of the oceanic movement that you observe, in terms of the various different oceanic waters and how do they circulate. We will study about these as well again in the portion of oceanography. This is relevant to us because now while we are reading about the various atmospheric phenomena, the complex atmospheric phenomena, these complex atmospheric phenomena, they influence the pressure on the oceans due to the movement of the winds. So that is why we need to understand this now. Now, let us understand the implied impact of this as well. Now, if I ask you basic questions here, very basic questions. When we talk about the presence of certain minerals and certain heavier minerals such as iron, etc., those nutrients, where do you think you will find them in abundance? In the lower regions, or will you find them in abundance near the surface? The nutrients like iron, magnesium, etc., calcium, will you find them to be abundant in lower regions or in the higher reaches? Right? This is a very common sense. It is experienced in the lower regions. The abundance will be experienced in the lower areas. Due to upwelling, this water, colder water, brings these nutrients like iron. And listen to this carefully, because a large portion of oceanic biodiversity is dependent on these phenomena. When recorded on satellite images, these present a very beautiful imagery of what is happening underneath these oceanic waters. So, these nutrients like iron, magnesium, calcium, etc., due to upwelling, they will be brought much closer to the surface. Earlier, they were present at a depth where even sunlight would not be available, but now they have risen up, they have come closer to the surface. In the presence of these nutrients and in the availability of sunlight coming from above, you observe the growth of the producer community in the oceans, that is, the phytoplanktons. Phytoplanktons are basically algal species. Phytoplanktons. These are algal species, and they are able to carry out photosynthesis. Okay? Now here, as these nutrients, they start to rise up, the availability of sunlight is also there. So both of these conditions present together, that is what allows the growth of these algal species. And they start to bloom, they start to grow in numbers. In fact, the region around Western North America and the region around Western South America, that is the eastern part of Pacific Ocean, when recorded over the satellite image, it indicates a very significant change in oceanic water coloration as observed, where the abundance of these phytoplanktons, that significantly starts to increase wherever upwelling is happening. And that abundance of phytoplanktons, that serves as food for many of the small microscopic zooplanktons as well. Zooplanktons eat the phytoplanktons. These phytoplanktons are also consumed by the smaller species of fish, very small, millimeters long, that is krill, right? Very small they are. Now these krill, they start growing in large numbers because of the availability of food. Now, when they start growing in large numbers, slightly bigger fishes, they also start growing in numbers because everybody now is getting enough number of food. And these large fishes, they will support slightly bigger fishes. Slowly and steadily, it goes up till the top of the food chain, where you have now the abundant food material which is present for even the big blue whales as well, which come into these areas and consume hundreds and thousands of these krills and small fishes in one big gulp. Nonetheless, wherever this event is happening, we will experience a significant spurt in biodiversity in that region, marine biodiversity, lot of fishes. So that always creates very good conditions for fishing activities. So wherever upwelling is happening, it is conducive for carrying out your fishing activities as well. Okay? So observe this. Here you have the warmer surface water which is carried away by the surface wind, and this is upwelling. Now that means deeper, colder, nutrient-rich water from underneath, that is brought up closer to the surface. That means the sea surface temperature, that sea surface temperature, that decreases, right? And there you will observe that phytoplanktons, the microscopic phytoplanktons is zooplanktons, they benefit because you have nutrient rich water now which is coming to the surface, closer to the surface, and you also have the availability of sunlight to provide and support photosynthesis. So that allows the growth of many fishes. And that is why upwelling, whenever upwelling happens, creates good fishing grounds. Okay? Now, if I take you back to the Walker circulation, can you tell me that during the Walker circulation, where is it that we experience upwelling? Is it across the western coast of Pacific or the eastern part of Pacific? During Walker circulation, where do you experience this upwelling? Very good, Pranay. Amit, good. Most of you are correct, apart from a few of you. So how does this circulation take place? In the Walker circulation, what is the circulation which happens? You have the winds, trade wind system blowing like this. So the surface water will be carried till the region of Western Pacific. That is where they will be pushed down. Meanwhile, in the Eastern Pacific, you will observe a kind of a rise. So here you will find upwelling in action. Upwelling in action. Okay, and here you will find downwelling in action. Downwelling in action, which is observed due to the Walker circulation. Okay, so that is your upwelling and downwelling. So basically, these are caused due to the movement of the wind pattern, and they can influence the sea surface temperature. Once the sea surface temperature is influenced already, the pressure systems created in such areas, they also end up getting influenced significantly. So winds blowing across the ocean surface, they push the water away, right? Water then rises up from beneath, not raises, rises up from beneath the surface to replace the water that was pushed away. This process is known as upwelling. Upwelling occurs in the open ocean sometimes and also along the coastline. The reverse process, which we refer to as downwelling, also occurs when basically the wind pushes the surface water to build up across the coastline, and then the surface water eventually sinks downward to the bottom. So this upwelling decreases the sea surface temperature. The sea surface temperature and this increases the sea surface temperature. Okay, that is the factor of upwelling and downwelling, right? Now, Jasmeet, will upwelling and downwelling be experienced only across equator? No, not necessary, my dear friend. Wherever you have that kind of an offshore, onshore wind, not the land and the sea breeze, a consistent offshore and onshore wind, like the planetary wind system across the coastline, they can always create upwelling and downwelling. Biswajit, but sir, in the process of Walker circulation, the nutrients are carried away as the water consistently rise up from the bottom. So as the nutrients they come up, it is not as if immediately they will be carried away. It is a gentle movement and a continuous movement of wind. These conditions of Walker circulation, etc., this is not something which is prevalent for one day. This can extend and exist for many seasons, right? Many months of the year is when you can experience this. So throughout the process, as there is consistent availability of more nutrients being drawn from the lower regions, simultaneously you will experience a thriving of the population of the phytoplanktons. So that is why this entire region will be very populated. Wherever you have upwelling, heavily populated with the fish population as well. Okay. Waves are occur due to this, Vijay? No. Waves are occur due to different reasons. Deepika, during high pressure, we observe downwelling always on water bodies. In most of the scenarios, that is not true. For example, in the case of Pacific itself, if you observe that where the high pressure is, it is Eastern Pacific and there upwelling is happening. So in most of the cases, that is not true. First of all, Nitesh, there is nothing as triple El Nina. There is triple La Nina. There is no triple El Nina. So triple La Nina, we have discussed in our target prelims portion. You can take a look at that. It is when La Nina phase occurs for 3 consecutive years. That is triple dip La Nina as it is referred to. And okay, right. So now we come to the portion of El Nino Southern Oscillation, or what is also referred to as ENSO. So this ENSO is a circulation which is observed in South Equatorial Pacific. It is observed where? It is observed in the tropical and, in fact, South Equatorial Pacific. It is still in the region of tropics, in the tropical Pacific, but slightly to the south of equator, almost around equatorial region, slightly to the south. Okay, Gokul, how can, a couple of questions I'll answer before moving forward. Gokul, how can warm water push down in downwelling? So warm water, when it keeps on accumulating and is brought by the winds, where will it go? Will you have a mountain of water in an ocean? No, eventually that water will exert pressure and you will have the water being pushed down. That is how the water basically is pushed down, and that is what we observe. Okay, and Himaya, you have received the answer. So now we come to ENSO, what is also referred to as ENSO cycles. So let us understand what do we mean by this. So first of all, people came upon and discovered El Nino. That was something which people came to discover first. And it was, first of all, discovered by few of the fishermen of the Peruvian coastline, of the coastline of Peru. That is when they experienced this or observed this. Basically, if you take a look at the location of Peru, if we take a look at the location of Peru, this is the Peruvian coastline. Right, this particular portion. Now here, if you observe, then during the months of November, December, January, and February, which condition of climate will prevail? Summer season or winter season? Which condition of climate will prevail during the months of November to February? No, Suvarna. It takes place in large oceans. Okay, good. Thank you. I was worried that I might have to talk about the entire aspect of rotation of Earth again. Okay, then let's do one thing. Let's find it out more clearly. Right? During November to February, Peru experiences summer, winter, spring. I'll launch a poll for this and let's take an answer. let's see how good of an idea we have about the rotation of the planet, something we covered in the first module itself. So, while we have 52% who have given the correct answer, we have a significant majority who has given the incorrect answer as well. We have almost 48% who has given the incorrect answer. The correct answer will be summer. It is not as if it is a winter month in India, the entire world will experience winter. Okay, let's not be so India centric that if it is winter in India, why will the world experience anything so different? We are an ancient civilization. The whole world should experience winter season. If we are please don't have that approach. It is a region which lies in the southern hemisphere. When you have winter in north, it is summer in south, and vice versa. There, the entire aspect of how old a civilization you are, how good people we are, how good food we cook, that doesn't come into play. So please never have that kind of a thing. Southern hemisphere has got a very different climatic condition as compared to northern hemisphere. I hope this is clear. Okay, I hope we don't have to go back to the actual tilt of the planet again. Okay, so during these conditions, during these months, Peru experiences summer season, right? Now, here, when we see the winds, the prevailing wind systems which exist during this time of the year, the prevailing wind system which exists in this time of the year, the Peruvian coastline will experience which winds? It will experience the trade winds. Now, these trade winds in the region of southern hemisphere will be in a direction like this. So these winds in the Peruvian coastline, will they be onshore or offshore? What do you think? Will these winds be onshore or offshore? It will be offshore. Trade winds will be offshore. Offshore trade winds. Now, offshore winds, do they bring rainfall or do they bring in dry conditions? What do you think? Offshore winds, do they bring rainfall or dry conditions? Dry conditions. Good. So we have reached a consensus that during the month of November, December, January, and February, the Peruvian coastline under normal conditions is dry, does not receive rainfall, and experiences summer season. I hope that is the biggest eureka moment for many of us today, that it experiences summer season, contrary to what we experience in India. We have some places which have the audacity to experience different seasons than what we experience in India. So, it was during the time of Christmas when you had very oppressive conditions in Peru. Oppressive in the sense it is very hot as well. It is not going to bring you any rainfall as well. So it is oppressive. Now, few of the fisher folk, when they started carrying out their activities off the coast of Peru, they suddenly observed that all of a sudden, around this later part of December, they experienced the oncoming of clouds and rainfall to happen in this region of Peru and Peruvian coastline. Now, normally in the month of December, you don't experience this or you don't even expect this to happen in Peruvian coastline. But this was when they observed that the Peruvian coastline is experiencing a lot of cloud cover and a lot of rainfall as well. So, as is the case in almost all the parts of the world, they thought it is the gift from the God himself, because it was the month of Christmas and they thought it is a gift from Christ himself. And that is where the phenomena of Peru receiving rainfall during these months, that was named as the Christ child, right? Which loosely translates into El Nino. So that was named as El Nino. Okay. Basically, after the fishermen made this discovery, for a long period of time, climatologists they understood that okay, El Nino might be a condition in Pacific, a atmospheric condition in the region of Pacific, due to which the Peruvian coastline experiences rainfall, or there must be a low pressure created around the eastern Pacific. That is why they are the regions receiving rainfall. After a couple of decades, when more finding was carried out, more experiments and more studies were carried out in the region of the Pacific, something very interesting was found. It was found that not every year do you experience the conditions of El Nino. You experience this condition of low pressure getting created over Peru, coming into existence every 3 to 4 years. The general trend at that point of time which was observed was that around 12 years time period was taken when these El Nino conditions would return, creating rainfall in Peru during these months. Simultaneously, it was also observed that whenever we talk about El Nino, not only we don't experience it every year, maybe every 2 years, every 3 years, every 4 years. That is maybe when we experience this. But then, at this time when Peru receives rainfall, Australia faces drought like conditions, absolute dry and drought like conditions. So, that is something which gave the scientists a clue that look, something different is happening in Peru, due to which Peru is receiving rainfall. Simultaneously, something is happening in Australia as well, due to which Australia is becoming very dry. Right? That is when they found out that during this period, the average temperature of the Pacific Ocean was significantly hotter. So they named this phenomena as the warming phase of the equatorial Pacific. They named this as warming phase of Pacific. Now, if there is a warming phase, that means it is not a regular thing. It is only a temporary thing. That is why phase. If I say that today you have studied 4 hours, so this is your studious phase, that means that in itself is a kind of God Almighty's gift that you have studied for 4 hours, right? So it is not your normal phase. It is something which is out of the ordinary. Similarly, they discovered that yes, there is a warming phase, but there is also development of a condition where Peru becomes very dry. Australia experiences significant amount of rainfall, so much of rainfall across Australia, Indonesia, etc., that it can flood these areas. That is a condition exactly to the opposite of El Nino. They named this condition, which again peaked during the months of November, December, January, and February, where this time Peru was absolutely dry. Peru would be absolutely dry and no rainfall at all, whereas Australia would be flooded, so much of rainfall. They thought it is a condition exactly to the opposite of El Nino. So they named it the girl child or La Nina. La Nina, right? So please don't call it El Nina or La Nino or El Nino or anything, all the mixtures that you kind of use. Please don't use it. El Nino, La Nina. Okay, please don't say El Nina and La Nino and all this in combination as you write oftentimes in your mail. It is very difficult for us to understand whether you are getting confused with El Nino or La Nina because you use a mixture of both of them. So be very clear what they are. El Nino, the Christ child, the boy child in a way, right? Not the exact meaning to be the boy child, but the Christ child. La Nina means the girl child, the opposite of El Nino. Now, the sea surface temperature was measured during this phase, and it was found that in general, the Pacific surface temperature is cooler for a larger part in this phase. So, this is also what was referred to as the cooling phase. of Pacific. Now the climatologists also realized that neither El Nino condition nor La Nina conditions, they don't prevail year after year. This is something that you are able to experience maybe every 2 years, maybe every 3 years. So what is the condition prevalent for most of the year under normal circumstances? So there must be a condition where one extremity is El Nino, the other extremity is La Nina. One extremity is Peru receives rainfall, other extremity is Australia receives rainfall. So there must be a normal ground as well, which prevails under normal conditions. Then it is acceptable that, okay, under one anomaly you have El Nino, under other anomaly you experience La Nina. So that is when they found that under natural circumstances, under normal circumstances, what they also named as the neutral phase. Neutral phase. That is present under normal conditions. Okay. So they found the presence of a neutral phase under normal conditions. And they found that this can change to El Nino, this can change to La Nina 1 year or the other. So that is where it was found out that under normal phase, the circulation that we observe is nothing but the normal Walker circulation. This is where you have normal Walker circulation which is observed. Okay? And it is here that the conditions keep on changing from one situation to the other situation year after year. They can change to El Nino, or they can change to all the way to La Nina. Now, because the conditions will oscillate between El Nino, La Nina and neutral phase, that is why this is referred to as El Nino Southern Oscillation. Southern here refers to the South Equatorial Pacific. Oscillation basically refers to the changing of conditions between El Nino, neutral, La Nina, neutral, El Nino, and again back to neutral or maybe a repetition of El Nino. So that is how the Pacific's temperature from cooling phase to a warming phase was experienced, and hence the name ENSO as is observed. Okay. Now here, when we talk about the ENSO conditions, we have to understand what do we mean by El Nino, why it happens. We have already seen neutral phase, that is Walker circulation, and also we know La Nina. We have to look at what is La Nina and how does it happen. Here you have to understand basically, if your tricellular model is in place in your mind, obviously, if you have an idea about where the trade winds are generated from, where do the trade winds blow from. So if you have that portion which is clear in your mind, it is going to be very easy. Sukanya, why can't it be spring in Peru? When, my dear friend? In November, December, January, and February. Where is it that you have spring during these seasons? And leave that. When is it that you have spring in India or autumn in India? Who told you it is November? Think about it. Right now, you are in the portion or you are studying geography. You are not reading those seasons and the seasonal variation that you had in your books where you had individuals wearing different clothes during different seasons. Autumn and spring happens when you have the condition of equinox which is achieved, when it is directly above, when the location of the sun is directly above the region of equator. It happens when you have the transition from the position of the sun transitions from the Tropic of Cancer in the month of or at the date of 21st of July to the Tropic of Capricorn on 22nd of December. Again, it retreats. So it lies on equator on two particular dates, that is 21st of March. That is what is referred to as equinox. That is considered to be a transition from winter to summer in the northern hemisphere. And then on 23rd of September, which is considered to be a transition from summer to winter in the northern hemisphere and winter to summer in the southern hemisphere. Okay? Please understand that November is not a month of this spring and autumn. And again, I won't ask you where the source that you have got it, but this is something that is generally taught in our childhood days, that December is the month to wear sweaters, the summer is the month to have bright clothes. That is what creates this impression that if it is winter in India, why the world will experience other conditions or climate. The entire world will experience winter season. That is why we see the kind of the polling results that we did. Okay. So here, just keep in mind the locational aspect of the sun, because now we are dealing with complex atmospheric phenomena where those sweater-born guys and their images, they don't work anymore. So that is what is ENSO or El Nino, Southern Oscillation. And oscillation, why it is referred to? Because the conditions, they change from one, maybe the warming phase of Pacific to the cooling phase of Pacific, back to the warming phase of Pacific. In between, you never know, for 2 to 3 years, you might have the existence of the neutral phase altogether. So this has a real impact on the global climatic condition. We will study how it impacts the Indian climate in the next module as well. But just to give you a brief idea, when we talk about El Nino creates lesser rainfall in India. Whereas whenever you have conditions of La Nina, they end up creating higher rains in India. Then neutral phase, when is in existence, average to above average rains in India. Let us understand how this happens. To start with, the neutral conditions. Neutral condition is nothing but a normal Walker circulation. So this is your normal. How India is affected, we will study in Indian climate. Normal Walker circulation. So under the normal Walker circulation, what is it that we experience? Trade winds, they help accumulate warm waters in the western equatorial Pacific Ocean, whereas the cold water, as a result of upwelling, emerge in the eastern equatorial Pacific Ocean. So where you have the accumulation of warm water, there you have the development of low pressure, and then in the eastern equatorial Indian Ocean, or rather eastern equatorial Pacific Ocean, you have the development of high pressure. This causes rainfall in the region of northern Australia, while due to high pressure, there is a lack of rainfall across the western coast of South America. So the Peruvian coastline and so on, they will tend to remain dry. So this is the condition which is observed under neutral conditions. Neutral conditions. So here you will find that the eastern equatorial waters, eastern equatorial Pacific waters, they are colder. The western Pacific waters, they are warmer, right? Now that creates a low pressure. This creates a high pressure. Now, in certain cases, what happens is that obviously these will drive surface winds. These will drive winds from high pressure to low pressure, isn't it? Now, these surface winds, as they are driven, basically, they will carry what? More surface water. they will start carrying more surface water along with it. Okay. Now, over a period of time, all that surface water which is being carried upon, that surface water starts to increase in aerial coverage. The area that is covered by this surface water, that starts to increase significantly. So the low pressure becomes intense. You have more warm water in that area. When the low pressure becomes intense, it will drive stronger winds. Stronger winds are attracted means what? A significant amount of upwelling action will take place. So even the cold area region, the region of cold water, that will also start to expand. So the low pressure intensifies. The high pressure eventually intensifies. And the circulation becomes much stronger. That is a condition which we refer to as La Nina. In the condition of La Nina, what do you observe? It is nothing but a strengthened Walker circulation. Think about it as a Walker circulation on steroids, if you will. So here the wind movement is much strong. And here the region where you have warm water, that has also expanded. The region where you will find the presence of cold water, that also you will find to be expanded. Isn't it? So the high pressure becomes much more dominant. Low pressure even becomes much more dominant. That creates a condition of very strong wind movement from east to west, and that is La Nina. La Nina, in a way, can be referred to as a strengthened Walker circulation. A stronger Walker circulation. Now, in which months of the year do we observe this? When is it that this happens? So the entire process can take almost an year to materialize. It can predominate for almost 7 to 8 months through the year. But it reaches its peak when? During the southern summers. And the southern summers happen when? November, December, January, February. That is when the southern hemisphere experiences a summer season. So that is when the conditions peak. Otherwise, they can be in existence, these conditions of high pressure, low pressure, they can be in existence for 8 to 10 months of the year. So let me write it down somewhere so that you have easy revision process. If at all you decide someday that now is the high time I have to start revising, for that day, let me write it down here. So the conditions prevail or rather can prevail. Can prevail for 8 to 10 months. However, they peak during southern summers, that is, in case you don't get confused, when is it that we have southern summers? That is from November up till February. So that is when these conditions are at their maximum, be it the conditions of El Nino or La Nina, that is when they peak. When we say peak means what? Peak means the low pressure will be much more stronger. It will be at its strongest self. The high pressure also will be at its most dominant self, most stronger self. So that is what you experience here. Now, it is not necessary that normal conditions will always lead to La Nina. No. Normal conditions can lead to El Nino as well. So it is not always necessary that it will always lead to La Nina. So Either the normal conditions can continue for 2 to 3 years, or you can have one of them continuing for 2 to 3 years. It has also been observed that from El Nino, it has returned to normal, and again El Nino. Again normal, again El Nino. Similarly, La Nina to neutral to again La Nina, again to neutral, again to La Nina. So that largely is driven by the wind movement across the region. Also, you have various other circulations happening within the Pacific Ocean as well. You have the presence of certain ocean currents in the Pacific as well, which bring water from various different latitudes into equatorial Pacific. So multitude of factors are at play. So what do the climatologists do? Are they able to predict it? So they are able to predict it. In fact, this particular year, that is 2023, it is predicted that it is going to be an El Nino year. Till now, we don't have the surety. And it is said that surety we will get in the next couple of months. So almost on a daily basis, temperature is consistently measured across both ends of the South Equatorial Pacific. You have various research vessels who continuously monitor the temperature. And then they calculate what is referred to as the Nino index, right? And thereby they are able to reach at the conclusion whether it is going to be neutral, whether it is going to be El Nino, whether it is going to be La Nina. For the past 3 years, India has experienced a condition of La Nina. Before that, in 2019, we had El Nino, which continued from 2018 onwards, right? So that is how these conditions, they keep on changing. Now, this is your La Nina. La Nina basically is where you will observe that the extent of that warm water, that has significantly increased. So the low pressure has increased, right? Now, under these conditions, which portion will receive rainfall, Australia or Peru? Which of them will receive rainfall? What do you think? Australia or Peru? Obviously, Australia. So during these conditions, Australia, in fact, Indonesia, Philippines, the entire region receives so much amount of rainfall, such huge quantity of rainfall, that it brings flooding and floods in these parts of the world. It is flooded. So that is what is brought in by these conditions, whereas Peruvian coastline remains very dry during these conditions, almost drought-like situation. So whatever happened under Walker circulation, it is significantly intensified. So these are the conditions where a significant low pressure develops over the western equatorial Pacific Ocean, while an intensified high pressure develops over the eastern equatorial Pacific Ocean. In a way, it is nothing but an intensified Walker circulation. Okay, a kind of an intensified. It leads to flood-like conditions across northern Australia, while leading to drought-like conditions in the part of South America. In terms of the impact on India, as we will study later in the next module, it augments or increases the amount of rainfall that we expect on an average to be received in India throughout the year. So it increases it significantly. So during La Nina conditions, India experiences excessive rainfall. Experiences higher rains. Yes, Siddhant. So this is what you observe in the case of La Nina. If you observe here, as compared to the El Nino circulation, if you observe, if I take you back to the El Nino circulation here, observe this one, the neutral phase circulation rather. Observe the neutral phase circulation. Observe that you have upwelling happening here, and look at the accumulation of warm water. Now, if I take you to the conditions of La Nina, observe the accumulation of warm water is also greater. There is a greater amount of upwelling as well, which is happening. So while in the Peruvian coastline, you will experience fair weather conditions, which are dry due to the high pressure, across the Australian coastline, you will experience very heavy rainfall, almost flood-like conditions which are created. This is your La Nina. Then we have a global circulation associated with La Nina as well. So here you observe that warmer waters, they are largely confined to the Western Pacific in significant proportion. But observe that colder waters, they have also spread out, right? So because the colder waters have spread out in the region of equatorial Pacific, that is why this is also what is referred to as the cooling phase. Cooling phase of the Pacific. That is why it is also what is referred to as the cooling phase of the Pacific. Now here again, you can have the conditions of this low pressure system traveling all the way to the region of Bay of Bengal, and that can cause again the formation of tropical cyclone. But look at the region of Western Indian Ocean, the Western Equatorial and this portion, you have the existence of a high pressure. Okay. Now, Suvarna, is it the same month for El Nino and La Nina? Yes, it is the same month. Obviously, in 1 year, you cannot have both El Nino and La Nina occurring at the same month. That is why it is a cycle which goes on for multiple years. Maybe once in every 5 years, you will have an El Nino. Maybe that can repeat itself for twice, 2 years continuously. We'll take a look at the yearly data record as well. Don't worry. Then we come to the conditions of El Nino. What is El Nino? El Nino, in simple words, is the reversal of the Walker circulation. In very simple words, it is the reversal of Walker circulation. Now, why does it happen and how does it happen? So for this, again, let's take the help of a very basic home experiment. Suppose you have a bucket of water here. Suppose. Let's suppose you have filled this water to the brim. Let's suppose. Now, on one side of it, you attach a large fan, a very large fan, which is able to generate very strong winds. The winds generated are in this direction. Now, if ever you have witnessed this, if you have not witnessed this, do one thing. Take a glass of water, fill it to the brim and start blowing on that water surface. So replace the fan with your mouth. So when you start blowing air onto the surface, same in this case, what will happen? Will the water remain undisturbed? Or will the water start accumulating in this area to the opposite of the placement of the fan? Or will the water accumulate in this region? What do you think? Will it accumulate at place A, B, or will it remain unchanged? What do you think? Good. So water will tend to accumulate where? It will tend to accumulate at B, or rather A here. Maybe some amount of that water will spill over as well. Now, your dad comes in and finds out, or your parents come in and they find out that rather than studying, you are carrying out these experiments. So they take the fan away from you. Now, the movement of air is suddenly stopped. So are your dreams, so are your ambitions, everything stops all of a sudden. The movement of winds, they suddenly stop. Now, what will happen to this accumulated water? Will you have a kind of a condition where in a bucket, the water is at some level for half a bucket, and for the remaining portion, the water experiences a kind of a swelling? Or will you have all that water spilling over eventually, slowly and steadily, that now, since we have come to the edge, there is no point, we have to jump? Or will you find that the water flows back and gains the normal condition again? What do you think will happen? It is basically going to flow back, isn't it? Right? It is something which can flow back here. So when that tends to flow back, then we will have the spread of water here. It will regain its natural and normal conditions. Right? Now, let us bring this concept into an area which is slightly larger than your bucket, that is the Pacific Ocean. Let us consider the Pacific Ocean. Now, under the neutral phase, under the normal phase, what do you experience? You experience that water is accumulated in the region of Western Pacific. That is where you have the accumulation of warm water. Now, this warm water, it has been brought here due to what? Due to the movement of the trade winds. The movement of the trade winds. So, these trade winds, they keep on acting like a fan, which would provide water here, or which would provide the wind direction here. These trade winds, they keep on acting like this fan. Now, this fan was taken away by your parents because they found it useless. Something similar can happen with the trade winds as well. So how is it that these trade winds are generated? If I ask you which portion or which pressure zone is responsible for the genesis or the birth of the trade wind, what will be your answer? Which pressure zone is responsible for the birth of these trade winds? What do you think? Nitesh and Bhavna, correct. And Neil also correct. Shamil, Meenu, correct. So, despite what your larger prevalent opinion might be, these trade winds would not have been driven if there would not have been a subtropical high pressure belt in existence. So these trade winds are basically supplied from where? You have subtropical high pressure belt. Now, by the way, these subtropical high pressure zones, which you experience around 30 degree, 35 degree, 20 degree, now these are situated in those areas which are generally hotter, isn't it? 20 degree, 30 degree north and south of equator, that is generally very hot. But how is it that we have high pressure in this area which is very hot? That is because in around 30 degrees, as we have seen in the portion of tricellular model of circulation, you have the air which is sinking from above, isn't it? That sinking air is the one which is creating this high pressure. It gets warmed up, the sinking air gets warmed up in the process as well due to adiabatic compression. Now listen to this carefully. It might happen. For example, in India, first of all, tell me that whichever place of the country do you belong from, is it the case that every year you experience the same summer season in terms of temperature, the same temperature in winter season? Or is it so that certain summers are hotter than the previous one? So do you observe a uniform condition during summer, or is it something which is variable year upon year? Obviously, you will say and you will adhere to the fact that certain years are much warmer, certain years are comparatively cooler. In certain years, the summer is very, very hot. In certain years, summer is slightly more pleasant. Same is the case with winter. Now, that thing can happen at 30° north or south as well. So, certain years are the ones where this region gets superheated. During certain years, these get superheated. Now, when these get superheated, and follow the chronology, when these get superheated, what about the air parcel immediately in this area? What will be the tendency of the air parcel here? This air parcel will also get warmed up. And because it has warmed up, what will be its normal tendency? Its normal and natural tendency will be to rise up. Because of warming, because of incredible rate of heating, it will rise up, isn't it? Now, it won't be able to rise up because there is a sinking air column, but nonetheless, it will at least try, right? Now, on the ground surface, think about it. Normally, you had sinking air continuously sinking, creating that high pressure on the ground. But suddenly, you have the air parcel which try to rise up. So, what will be the condition of the high pressure on ground? Will the high pressure intensify as compared to the earlier situation, or will the high pressure weaken considerably as compared to the earlier condition? What do you think will be the resultant? It will weaken, isn't it? This high pressure that weakens. High pressure weakens. Now, the trade winds, they are driven by this high pressure zone. Stronger the high pressure, more will be the pressure gradient force and stronger will be the trade winds. But if this subtropical high pressure zone in total, if that gets weaker, what will happen to the trade winds? Will the trade winds be unaffected? That fair enough, do whatever you have to do with the pressure zone. My job is to carry warm water. I will do that. Will the trade winds simply ignore it? Will they strengthen, or will the trade winds also weaken? What do you think? Beautiful. The trade winds will also significantly weaken. So when the subtropical high pressure zone that weakens, that leads to significant weakening. By the way, this weakening that you see, this is an absolute temporary phenomena. This is not a permanent phenomena. It will only come into existence for a few months, right? Again, next year, you can have the same condition. Temporary significant weakening of trade winds. Now, it was these trade winds which was carrying all the warm water and accumulating that warm water under normal conditions in the region of Western Pacific. Now, just like your parents took away your fan, similarly, these winds, they will also weaken and disappear. When they will weaken and disappear, what will happen to this accumulated water? Over a period of time, as this movement and accumulation takes place, at the peak of it, under normal situations, the water is higher in this portion by almost around 8 to 10 centimeter. That is the height that the water gains in this area. So that just like the bulge you had in this portion of the bucket, similarly, water tends to develop a bulge in the region of Western Pacific. Now, the trade winds have fallen away. They have weakened in this region. Why have they weakened? Because of weakening of the subtropical high pressure zone. Why is it that the high pressure zone has weakened? Because of unnatural heating received during certain years in the tropics. Now, what will happen to this warm water? Will it remain as it is? Will it flow back? What do you think? Very good. This warm water which was accumulated, this, in the lack of winds, they will initiate a kind of a flow back. So if you have to think about it, you can imagine that all this warm water, that will initiate a kind of a flow back. Depending upon how much the accumulation was there, if the accumulation was significant, they will flow back for a larger distance because of greater potential energy. If the accumulation was less, they might end up moving only to the region around Central Pacific. But mostly, all this warm water that flows back and starts accumulating in the region of Eastern Pacific. Now you have the creation of warm water region in the area of Eastern Pacific. Rather than the Western Pacific, now the region of Eastern Pacific has got the accumulation of this warm water. So this will create on the ground surface or on the sea surface what pressure condition? It will create a low pressure condition. It will create a low pressure condition, right? Now, low pressure means what? Winds will be attracted from all directions. So winds will be attracted from here. Winds will be attracted from here as well. Isn't it? These winds which are going towards this warm water, they will further carry on the surface water and they will keep on accumulating the surface warm water. So the region where you have the surface warm water, that keeps on extending. Now, as a consequence of it, on the region of the Western Pacific, you will experience upwelling here. So here you will experience upwelling. Upwelling leading to creation of a high pressure. That high pressure, why? It is a comparative high pressure. It is not a strong high pressure. A comparative high pressure as a result of upwelling event which has happened because the wind direction in general, the wind movement in general was like this. So all that warm water keeps on accumulating. Overall, the size and the area of that warm region, that keeps on extending. So that is why this is a phase where the Central Pacific becomes very warm. And that is why it is also referred to as the warming phase of the Pacific. Warming phase of Pacific. Now, under these conditions, which area will receive rainfall? Australia or Peru? Which area do you think will receive rainfall? Beautiful. It will be Peru, isn't it? There will be Peru is the region which will receive rainfall, and Australia will be dry during the months of November, December, January, February, when Australia experiences the stronger summer season. That is when Australia will receive lack of rainfall, complete lack of rainfall. So this condition, this situation drives the drought-like conditions in Australia. Many of the times, these dry conditions, that too during the summer season, can initiate wildfires and forest fires in the region of Australia as well. That is what we refer to as El Nino. Generally, El Nino event is associated and generally it is related to the aspect of weaker rainfall in India or lesser than average rainfall received in India. So here, if you observe the entire phenomena, so earlier you had strong winds, the trade winds, which would basically keep the accumulation of the warm water. When the trade winds would weaken significantly, that is when this warm water would start flowing back here. Now, once you have the accumulation of warm water here, it will be low pressure, it will drive in more winds, and that is what will further increase the accumulation. It is going to lead to a reversal of the Walker circulation. So, due to weakening of trade winds, the accumulated water across the Western Pacific starts to flow back, leading to redistribution of warm and cold waters. These warm waters sometimes can stay only up till the region of Central Pacific. They don't have enough power to go to Eastern Pacific. Sometimes they can drive all the way to the Eastern Pacific. So it depends on how much accumulated water is there to flow back. Okay, due to this, there is change in weather conditions, leading to drought-like conditions near Australian coastline and causing floods across the Peruvian coastline in general. Okay, right? So this is your El Nino circulation. So observe in El Nino circulation, this is the entire region where you have the warm water, and this is the area where you have colder water, that is high pressure. And here you have the low pressure. So that is how you have El Nino, La Nina conditions and neutral circulations. Again, I will repeat the entire thing about El Nino. So El Nino, under neutral conditions, listen to this carefully. Under neutral conditions, what happens? You have accumulation of warm water across Western Pacific around the region of Australia and this area. That is where you have accumulation of warm water. Now, this accumulation is supported by the strong trade winds. Now, in certain years, the trade winds will weaken. Why? Because the subtropical high pressure zone, that in itself tends to weaken. Why does the subtropical high pressure zone weaken? Because of increased heating created in the region of the tropics in certain years, due to which the sinking air mass is countered by the rising column in certain regions, due to which the entire pressure zone weakens. So the pressure zone weakens means the trade winds will also weaken. That means the system driving the accumulation of water in the Western Pacific, that has weakened. So the accumulated water will tend to flow back, just like in the case of the bucket that we had seen. It flows back, it comes to the region of the East Pacific. That warm water now becomes an area of low pressure which has come into East Pacific. It will start attracting winds towards itself. That means more surface water will be brought towards the East Pacific, and this time upwelling will happen because of the wind movement in the West Pacific. That is what creates the counter Walker circulation, which we refer to as El Nino. Okay, right? Now, this is the impact on monsoon in general. So as you can see, year 2004 was an El Nino year, and that was the drought year. We received only 88% of the rainfall. 2005 was a neutral year again, and this continued for 2 years, where we experienced significant amount of rainfall. And this represents how much rainfall we have received as compared to the average. So let's say the average annual rainfall received in India during the monsoon months is taken as 100%. So this represents only 88% of that happened, or 103% of that rainfall is experienced. 6 and 7, it reverted to La Nina. So you had 110 to 105% of the rainfall received. Then 9 was again something which reverted to El Nino. It was a very strong El Nino. You had a severe drought, which with India receiving only 79%. Then 2010 and 11, again La Nina years. So you had 100 and 104%. 12, mild Nino in a way, and 13 was again neutral. For the past 3 years, that is 2022, 2021, and 2020, India has been experiencing continuous La Nina conditions, which is a very rare phenomena where consistently for 3 years you experience La Nina. So that is what is referred to as triple dip, La Nina. Conditions for 3 years continuously. That is why, and various different weather stations, etc., they also indicate the trend that 2023 it is expected to be an El Nino year. In fact, the Japanese meteorological department has already confirmed that it is going to be an El Nino year. We are waiting for more findings to come out, and it is expected that by the April end we shall be able to understand that which way the Pacific is going to behave in this and next year. Okay, between neutral and La Nina conditions, which will bring more rainfall? Always La Nina conditions. This was a question which was asked. Let's see. So I'll read the question, then I'll open it up for the polls. La Nina is suspected to have caused recent floods in Australia. How is La Nina different from El Nino? These kinds of questions are asked in prelims. La Nina is characterized by unusually cold temperature in equatorial Indian Ocean, whereas El Nino is characterized by unusually warm ocean temperature in the equatorial Pacific Ocean. El Nino has adverse effect on southwest monsoon of India, but La Nina has no effect on the Indian monsoon. So which of these is correct? I will give you the option. I'll give you 30 seconds. Umesh, El Nino, La Nina, my dear friend, exists only in the Pacific. The impact is felt in the nearby region, but it is not a global phenomenon. It is a phenomenon of the Pacific. Okay. Majority of you, as suspected, have given the incorrect answer. Congratulations for that. So here, if let us take a look and analyze this again carefully. So most of you have committed the mistake, I presume, in the same place where UPSC wanted you to commit mistake. Let us see. La Nina is characterized by unusually cold ocean temperature in equatorial Indian Ocean, whereas El Nino is characterized by unusually warm ocean temperature in equatorial Pacific Ocean. Have we studied about Indian Ocean till now in case of La Nina? All those who have marked A as correct, have we even touched the portion of Indian Ocean? Absolutely not. Incorrect. El Nino has adverse effect on southwest monsoon of India, but La Nina has no effect on monsoonal climate. We have seen that La Nina is always associated with slightly greater rainfall. La Nina associated with greater rainfall. So the correct answer in this, D, neither one nor two. Trust me, all the students who committed mistake in this, none of them committed mistakes because they did not know what El Nino was or what La Nina was. All of them have committed mistakes because they are unable to look and spot this trick that UPSC played with them. UPSC played this trick again. And again, it succeeded in leading to many of the good candidates committing mistakes in this type of question, which we will analyze after the break. Before that, we will take a look into Indian Ocean dipole, but we'll take a break, and then after that, we will take a break. Okay, we'll carry it forward. So let's take a break, and we'll take it for 15 minutes or 10 minutes. Will do. What do you think? Let's do one thing. Let's carry it out for 10 minutes. 15, is it? We have to cover the syllabus as well, guys. So, okay, fair enough. Let's take 15 minutes. Okay. A confirmation regarding the audio, please. If you're able to hear me out, thank you. So, till now, what is it that we have seen? If we have to, let's say, in a way, if we have to get this sorted and we have to look at the conclusion of it in a nutshell, we can always say that different ends of the Pacific, they experience different temperature. And due to that, you have different pressure zones created at both ends of the Pacific, which drives the wind movement. And that wind movement will have its implications across the equatorial region and the central equatorial region in all the oceans as well. Right? You'll agree to this? Now, this different portions of the Pacific getting heated at a different rate has been primarily caused by the movement of the winds. The winds are driving warm water to a region. The winds are bringing cold water in different areas. Now, a similar heating and cooling, that is differential heating and cooling, is also experienced at the region of the central Indian Ocean, where the eastern Indian Ocean, eastern point of the Indian Ocean, that is around the region of Indonesia, Sumatra, Java, the Southeast Asian nations that are there. So that portion and the western end of the Indian Ocean, that is around the coastline of Africa, both of these, they end up exhibiting or they end up representing slightly different temperature. That different temperature can even be in the margin of 0.3, 0.5 degrees Celsius. But nonetheless, that difference in temperature across both ends of Indian Ocean, that can also drive a significant atmospheric circulation on its own. This phenomena is basically controlled by different rate of heating by the sun. This phenomena is actually contributed to by the heating of the land masses as well. And that is where it is not primarily driven by the wind action, but nonetheless, it leads to different temperatures observed across both ends of the Indian Ocean. And that is what we refer to as the Indian Ocean dipole. Dipole means two poles. That is what is the meaning of dipole, right? Existence of two poles. What are these two poles? The two ends of the central Indian Ocean, the eastern and the western point. So, this is also called as the El Nino of the Indian Ocean. Okay? And the Indian Ocean dipole is defined by the difference in temperature between two areas of the Indian Ocean, that is, a western pole near the Somalia coast and an eastern pole in the eastern Indian Ocean south of Indonesia. Across both of these two ends, that is here and here, there's a difference in temperature observed. Now, this difference in temperature which is observed, that is driven due to differential rate of heating, the properties of the landmass nearby, oceanic circulation, etc. So IOD is a sea surface warming phenomena with different regions of the Indian Ocean heating up at a different rate due to the properties of the nearby landmass. It might happen that the Indonesian region receives more heat or experiences more stringent summer. It might happen across the region of Africa as well. So whichever landmass gets heated more, nearby water body will also be influenced by that heating. The existent wind system, the oceanic circulation, because of all these, different ends of the Indian Ocean develop a differential rate of heating. So this induces a thermal pressure difference across the eastern and western end of the Indian Ocean. That is where you have a thermal pressure difference which is created, which in turn, once this pressure difference is created, that in turn initiates atmospheric circulations, and those atmospheric circulations which are initiated by this, that also impacts the circulation initiated by the ensocycles. Because the ensocycles we have seen, they have an influence over the Indian Ocean as well. And that is what indirectly influences the climatic conditions in India. So these Indian Ocean dipole, they can counteract, they can provide a counter to the impact created by the Enso cycles, especially over the Indian subcontinent when it comes to the amount of rainfall received. That is what we know as Indian Ocean Dipole, or IOD. Here, if we have to understand it, think about this as the equator, right? Let's assume equator. Okay. Let's do one thing. I hope looking at it, you will easily understand that this is equator. But still, let's mark it up. Now, under normal conditions, under natural normal conditions, observe the sea surface temperature and look at the impact of it. Now here, if you observe the portion of the Eastern Indian Ocean, observe this area, this entire terrain, or this entire region consisting of the water body as well. Now here you will find that the water body which is prevalent, the water body which is present, you'll find that the water body is present, is trapped between the various different land masses in general, isn't it? Here you will have a lot of land and in between them you have water. In general, due to heating, when we consider land and when we consider water, if I consider this to be the land and if I consider this to be the water, in general, during heating, which gets warmer, significantly warmer? It is always the land which gets heated up quickly. Isn't it? Very good. Gets heated more. The land gets heated at an incredibly greater rate. It gets heated much more. Now the water which is present, which is trapped here, that water that you see in between the various island regions, etc. Because of this excess heating of the land, the water has got no other place to go. So water will also get heated up, isn't it? So under normal conditions, the eastern part of the Indian Ocean, that gets heated up. Under normal conditions, due to heating of the land, Eastern Indian Ocean comparatively because always in comparison to the western portion, comparatively heats up. Now when this heats up in this area, it will create a condition of low pressure. Here it will create low pressure condition. Now when that low pressure condition is created, means what? It will attract winds from all directions. Now the winds which are attracted, what conditions of pressure and temperature will it create across the western part of Indian Ocean? Here, if the winds are getting attracted from here, so what is the condition of the sea surface temperature which will be created? What will be the impact or the pressure condition which will be created? Very good. Here, because of upwelling which will happen, here you will have the creation of a high pressure. And that will induce a circulation here. That will induce a kind of an atmospheric circulation as well, where the air will rise up in the region around the Eastern Indian Ocean. As the air rises up, it forms very dense, very thick convective clouds. These clouds will bring significant amount of rainfall in the region, very heavy amount of rainfall in the region, whereas the western part of Indian Ocean, that is going to remain dry. So this is what exists under normal condition. This is also what is referred to as normal phase. Normal phase. Now, when or during which month is this experienced? Like we have seen in El Nino and La Nina, that it exists for 6 to 8 months, it peaks during November to February. What about Indian Ocean Dipole? So, Indian Ocean Dipole does not follow any such seasonal variation. In the case of Indian Ocean Dipole, I repeat, it does not follow a seasonal variation. Indian Ocean Dipole, the temperature across both ends of the Indian Ocean, that is measured on a daily basis. That is something you will find as a measurement tool in the Indian Meteorological Department website as well. On a daily basis, temperature is measured. And then we get to know that whether you have a normal phase, a negative phase, or a positive phase. So that is where you don't have a seasonal bias or a seasonal existence of this IOD phenomena. It can change from week to week. It can change from month to month. The main agenda or the main point of concern is what is the condition which prevails when India receives its monsoonal rainfall, because that is what matters to us. So Indian Ocean Dipole not only interferes with the ENSO-atmospheric circulation, but by creation of a competing low pressure and high pressure system in the Indian Ocean itself, it ends up influencing rainfall received in India, whereby the positive phase of Indian Ocean Dipole, that brings incremental rainfall. Positive phase of IOD, that brings increased rainfall in India. Whereas when we talk about negative phase or even neutral phase, it brings decreased rains in India. Decreased rains in India. Now, obviously, you will have a question. What is this positive phase? What is this negative phase? What is this neutral phase? So just like the ENSO circulation, here also, in the case of Indian Ocean Dipole also, just like the neutral circulation or ENSO circulation, here also you have the existence of different phases. You have the positive phase, you have the neutral phase, and you also have what is referred to as the negative phase. So here also you have a variation from neutral to positive to sometimes even negative. Okay. Now, let us take a look at the different phases. So here, this is the neutral phase, which normally is in existence, and that is created how? By heating up of waters in the region. By heating up of water in the region. How is that water heated up? By the heating of the land mass is nearby. That is where the water also gets influenced. Now, when you have warmer water, the temperature difference, let's assume, if the temperature here is 24.5 and here the temperature is 24.2, that minor difference of 0.3, that is enough to drive an atmospheric circulation. Okay, you don't need the difference in temperature to be 4 degrees, 5 degrees. No, even a 0.2 or a 0.3 of a temperature change can initiate a comparative low pressure or a high pressure created due to thermal difference. So that in itself drives the winds towards the eastern part of Indian Ocean, and this reduces the rainfall, reduces rains received in India. Why is it that these winds come into existence? These winds are purely driven by the creation of this low pressure. These winds, they are driven only by the creation of this low pressure. If this low pressure would not have been in existence, you would have observed the normal trade winds to blow. It is because of this low pressure that these winds have come into existence. Now, the winds have come into existence. These winds, as they are moving, they will be dragging the surface water along with them, isn't it? They will be dragging surface water along with them. All this surface water, warm surface water, the winds will be dragging along with them. So here, you will, after a point of time, you will experience a greater accumulation of this warm surface water. When there's a greater accumulation of warm surface water means a more intense low pressure. More intense low pressure means stronger winds. Stronger winds mean here there will be greater upwelling across the west, more significant high pressure. This will keep on feeding itself till it becomes very, very intense. A very intense phase of the neutral circulation in IOD, that is what we have as the negative phase, right? So here you have a significant accumulation of warm water in the region of the Eastern Indian Ocean. And here you will observe that the western part, that is where you have the high pressure. Now, under these conditions, which area out of Arabian Sea and Bay of Bengal, out of these two, which area will experience more tropical cyclones? What do you think under these conditions? Very simple. It will be Bay of Bengal, because Arabian Sea is having high pressure, and for tropical cyclone you need a low pressure. Here the warmer waters might lead to the genesis of a low pressure cell or a cyclonic circulation close to around Andaman Nicobar Islands as well. So that is how you have the negative phase. This again significantly reduces the rains in India during monsoon. Okay? Then sometimes what happens, that you have the region of African coastline, that is what we also refer to as the Horn of Africa, the region around Eritrea, Djibouti, Kenya, Somalia, etc. Now that area also receives significant amount of heat. During certain years, those regions, they get superheated. So corresponding water body nearby, that is the Western Indian Ocean, also gets superheated because of the heat experienced in that area, due to which you have warmer regions and heating of water in this area. When you have that which happens, heating of water or accumulation of warm water in that area, that will initiate a low pressure here. Again, why is it that we will have warm water? Because of the heating of the African coastline and the Arabian Peninsula, right? So that is where the region around Saudi Arabia, Oman, etc., along with the Horn of Africa, that is Somalia, Eritrea, Djibouti, Kenya, all these countries, when they get superheated during certain years, they will be able to provide that heat or pass on that heat to the water as well. So the water also gets superheated up. And when this water gets heated up, it will create a low pressure condition that will now drag winds from the eastern part of Indian Ocean, causing upwelling in that area and creation of a high pressure. So this is the reversal of the circulation that you observed under normal phase or even the negative phase. This is what is referred to as a positive IOD. This will enhance the rains in India during monsoons. Now, during these conditions, Which portion, Arabian Sea or Bay of Bengal? Which portion is more liable to experience tropical cyclones? What do you think? Very good. Under these conditions, you will find that the Arabian Sea develops frequent occurrences of tropical cyclones. Okay, but under normal conditions, negative conditions in both of them, Bay of Bengal would support cyclonic development. Now, this IOD phenomena, as you can see, it induces an atmospheric circulation around the region of equator. You can see that, isn't it? Now, if I take you back to maybe this slide, yeah. La Nina conditions or El Nino conditions, they also initiate a circulation around the equatorial area. And we have seen, observe this area, they also initiate a circulation. And then observe this particular region, IOD. They also initiate a circulation in the same area. So that is why sometimes the IOD phenomena is able to either counter the impact of ensocycles or magnify the impact of ensocycles in certain situation. For example, the best case example in this is the year 1998. 1998 was predicted to be an El Nino year. And that was the strongest El Nino. 97-98 was the strongest El Nino of the previous century. So India was expecting a severe drought-like condition. Even though India did receive slightly lower than average amount of rainfall, but it was nowhere near a drought. It received much more than what was expected. Later on, meteorologists and climatologists and oceanographers, they carried on their studies and they found out that during this phase, the impact of El Nino was countered by a positive IOD. Sometimes you have La Nina phase, which is beneficial for Indian monsoon, further acting along with the positive IOD. That further accelerates the amount of rainfall that we receive. For example, if you take the amount of rainfall received in 2020, it was significantly more. So in 2020, we received close to around 110% of the average rainfall. So that is how this can add on, or this can basically nullify the impact of ensocycles created on India. That is all that you need to know from a general studies perspective for this particular portion. And I bring you to the question where again UPSC played the same trick, and this was a question asked in 2017. I know few of the toppers who, even though cleared the exam with good rank, but all of them, they got stuck in many of them, they got stuck in this question. So with reference to the Indian Ocean dipole, sometimes mentioned in the news while forecasting Indian monsoon, which of the following is or are correct? IOD phenomena, whatever it is characterized with, and IOD phenomena can influence El Nino impact on the monsoon. So I'll launch a poll and I'll give you 30 seconds. Amit, yes. Good. Thankfully, this time majority of you have got it correct. Very good. So here again the same catch was played. IOD phenomena is characterized by the difference in sea surface temperature. So by the time that you have read this much, already your mind begins to get tired and you feel that, okay, this much of the statement is correct, rest of it will also be correct. Between tropical Western Indian Ocean, till here it is correct, it will be correct. And tropical Eastern Pacific Ocean. Tropical Eastern Pacific Ocean is near the Peruvian coastline. Does the IOD mean the difference between the temperature in these two areas? No, it has to be Eastern Indian Ocean. This is incorrect. Then, an IOD phenomena can influence an El Nino's impact on the monsoon? Yes. So here you will have the answer as B. That is 2 only. Okay. Here the portion Pacific is incorrect. Okay. Right. Shouldn't be equatorial, western, tropical western, equatorial western. See, equatorial western lies within the tropical portion itself. So that is not which is so repenting in a way. That is not absolutely wrong. It is the Pacific which is absolutely wrong. An IOD phenomena can influence El Nino's impact on the monsoon. Yes, that is what I have been saying, Prashant. That is where I gave you the example of 1998, where an El Nino impact was nullified by the presence of a positive IOD. So, because it initiates a circulation in the same area where the IOD or where the Enso cycles have a circulation in the central Indian Ocean. Okay. Is positive phase of IOD referred to as La Nina? Absolutely not. Absolutely not. Because what is La Nina? La Nina is accumulation of warm waters in Western Pacific. What is positive IOD? Warm waters in Western Indian Ocean. So they are very different. Vipin, what do you mean by that? Prefer a book of MCQ to solve? See, we are going to solve the previous year questions. Okay. So whatever is required or needed by you, we will do that. Okay. Vipin, kindly write a complete sentence. Look at how much time it takes. Now you have written geography question mark. Yes, this is a geography session. La Nina and positive IOD can bring more rainfall in India. Yes, Ananya, that is correct. In monsoon, Karthi, increases and reduced rain in India according to IOD. So yes, a positive IOD, Karthi, increases the amount of rainfall. And this is where we have written positive IOD increases the rainfall in India, and negative IOD reduces the, and normal phase also reduces the rainfall in India. If there is low pressure in both the poles, you cannot have the same temperature at both the region. Any of them will be slightly greater or slightly lower. Vipin, that in itself will initiate a kind of a temperature pressure difference in general. Okay. No, it is neither the El Nino will influence IOD nor the IOD will influence El Nino. Both of them influence the amount of rainfall received in India. Okay. Kivika, is IOD the biggest influencer of Indian monsoon? Absolutely not. No, it's okay, Vipin. We are going to cover this and the MCQs, the previous year questions. That is the aim. Okay, the aim here is to give you the crux and to help you analyze your performance as per the previous year questions. If you are able to justify your performance here, that is more than sufficient. For that, for more practice, that is why we have separate prelims test series. That is why we have the unit tests as well. That is why on Saturdays we have the BHLP tests where you get 20 more questions to practice. So in one batch, you get almost 80 to 100 questions to practice other than the PYQs. And then you have the prelims test series. So obviously you will have a lot of questions to practice, provided that you do so. Okay. How is it that positive IOD enhances rainfall in India? We will come to the Indian monsoon, then we will take a look at it. Okay. How will La Nina enter India? All the impact of El Nino on India, La Nina on India, the neutral phase on India, the positive IOD on India, negative IOD. We'll come to it when we talk about Indian monsoon in the next module. We will take that up. Don't worry. Now we come to another phenomena which is referred to as the Madden-Julian oscillation. What do we mean by this Madden-Julian oscillation? Let us take a look at it. So basically till now, what is it that we have seen? We have seen that the region around Pacific develops a differential pressure due to which there is a circulation in the region of Pacific. We have seen that the region of Indian Ocean, that also develops different temperature, which induces differential pressure, which also induces a circulation. Then, even in the portion of Atlantic for that matter, even though Atlantic is not very broad at the region of equator, but still in the region of Atlantic also you have a minor circulation which is initiated at the two ends of equatorial Atlantic. But these circulations that you observe, these circulations, they are generated in these oceans, they remain in these oceans. Now, that was the larger understanding. It was in 1970s, the early 1970s, 1971-72, when you had two climatologists who traveled all the way to the region of Singapore to study the equatorial climate. How is it that equatorial climate behaves? Now, there they experienced something very unique. They observed that in every 30 to 40 days period, there is a phase where the region receives very heavy rainfall. And then again, it repeats after every 30 to 40 days. Later findings indicated that indeed there is a pressure system which is traveling. It is not static as is the case with El Nino, La Nina or Indian Ocean dipole. It is a pressure system which is traveling. And it is traveling as per the rotation of the planet. The planet is moving from west to east. So this pressure system is also traveling from west to east. So they named this circulation created by these moving pressure zones as the Madden-Julian oscillation. Based upon their very own names, that is how the name was given, Madden-Julian oscillation. So what is this Madden-Julian oscillation? This is an eastward moving disturbance of clouds, rainfall, winds, and pressure that transverses, covers the entire planet in the tropics and returns to its original position in around 30 to 60 days on an average. Each of the cycle lasts for around 30 to 60 days in general. That traveling system, imagine it to be like a conveyor belt system, like the escalators that you have in your malls, right? Or the airports, where you have the same set of material, they go down, they recirculate. Similarly, across the planet also, you have a system which is traveling eastwards continuously. As the planet rotates, this system also travels. Here you have a central portion which is a low pressure region, and then air comes into that area, rises up, diverges, and creates two competing cells of high pressure. Cells of high pressure. And this entire setup, that in itself ends up traveling. So here the first question which will surely come into your mind is, what is this? What are you saying? Somewhere you are saying Pacific Ocean is circulating, somewhere you are saying Indian Ocean is circulating, now you are saying this entire circulation itself is circulating. That is how the atmospheric circulation is filled with various different individual phenomena, individual occurrences. Till today, and you can say this with surety, till today, nobody has completely understood this Madden-Julian oscillation. All that people know is that it starts in the region around Africa. That is where it is initiated. And that is where initially a low pressure system is created. And you have initially the formation of, due to intense heating, especially in the region of Western Africa, you have a very significant low pressure system which is created. This low pressure system will attract winds. The winds will rise up, and then they will diverge. They will have to sink somewhere, isn't it? So let's say the winds sink here. The winds sink here. So on the ground, they will create high pressure systems. Now, wherever you have the low pressure, there you will find very thick clouds, leading to very heavy rainfall, right? But what about the high pressure region, this region? Tell me about the conditions that you will experience here in terms of rainfall, in terms of temperature. First of all, rainfall. Rains, high, low, normal. What do you think? Beautiful. Lack of rainfall. Lack of rains. Isn't it? Temperature, higher, lower. What do you think? Temperature? Now, this is where the catch is. This is the equatorial region, equatorial or the tropical region. So in general, the amount of insolation is high, isn't it? Insolation is high. Solar insolation, the amount of heat received from the sun, that is very high. We also know that air is sinking in this region. That air will get compressed ever so slightly, isn't it? When this air gets compressed ever so slightly, there will be heating. Few of you pointed this out, and Vaishna was correct in this, Mohana was correct in this. Few of you pointed this out. Deepak was also correct. So here, due to that heating, you will have higher temperature, isn't it? So here, let's name this place A. This place A, which at the time of its origin, this place A lies across the region of Western Indian Ocean in a way. That is where it originates. Now this place A is dry, receives higher sunlight, greater temperature. So over a period of time, can we not say that this place A creates very ideal conditions for the creation of a low pressure? But what about the existing low pressure? We already have an existing low pressure. Let us analyze the impact at this low pressure region, that is B. Now, at the region of B, we have very high rainfall because of the low pressure, convective rainfall. What will happen to the temperature at B? Temperature, due to excessive rainfall which is happening, what will be the impact on temperature? What do you think? Perfect. Temperature decreases. Right? Comparatively, over a period of time, this tends to become cooler. This tends to become warmer. Isn't it? As that region A becomes warmer, now if its temperature is higher than the low pressure at B, slowly and steadily you will find that this low pressure travels here. And instead of this low pressure, this gets converted into a kind of a high pressure. So now you have low pressure at A and a high pressure at B. So this A, when it is having low pressure, it will have another arm having a high pressure as well. So that is how the entire circulation that ends up traveling in a 30 to 60 day period. For most of the phases, so MJO, even though for general studies, please understand your requirement first of all. You should be knowing, otherwise I don't want any of you to start studying the various different journals and research papers on the subject. Leave that task to me. For you, it is not required. For your general studies, all you need to know is what is this MJO? So MJO is a traveling circulation system. Where does it exist? In the equatorial conditions, in the tropical conditions of the world in general. And how much time does it take to travel? 30 to 60 days. And what are the various different phases of MJO? In which direction does it travel? It travels in a west to east. Now, when we talk about the MJO and the entire cycle, you will find that you will have two distinct phases, right? So here you will find you will have a region of low pressure and a subsequent region of high pressure. High pressure. Observe how big the circulation is. Low pressure is in the region around central and eastern Indian Ocean, and the high pressure is almost around the region of western Pacific. Okay, so these are huge circulations. So that is where in the region of low pressure, can we not say you will have increased amount of rainfall, very intense low pressure, increased amount of rainfall. Wherever it is lying, that low pressure over Arabian Sea or over Bay of Bengal, it will lead to causation of cyclones as well. Whereas high pressure, dry conditions, lack of rainfall, higher temperature as well. After some time, this low pressure will travel here. This will become high pressure, and this will have another high pressure here somewhere. That is how the entire system circulates. So, if you have to classify these two phases of low pressure and high pressure, the MJO can always be classified as the phase of enhanced rainfall and the phase of the suppressed rainfall. So wherever you will have that low pressure, which will attract winds, the winds will rise up. It will lead to the formation of very dense and thick clouds. Simultaneously, the wind diverges. It will sink somewhere. So here and here, you have high pressure. So this is the phase of enhanced rainfall. Phase of enhanced rainfall. And this is a phase of suppressed rain. Phase of suppressed rains. Okay, that is all that you need to know. You have the development of MJO happening in 8 different phases. First phase lies over Africa, second, third phase lies over the Indian Ocean, fourth phase comes over the region of Indonesia and West Pacific, fifth, sixth phase lies over the region of the Pacific, seventh and eighth in the eastern and some part in the Atlantic. So you have an overall 8 different stages of the development of MJO, but not at all required even for your optional. I don't think that is required. This is something that you need to know, because whenever the MJO cycle occurs, it brings about increased occurrence of cyclones wherever you have that low pressure phase. Wherever this lies, this low pressure phase, right, it can always augment or increase the probability of occurrence of cyclonic circulation as well. If MJO occurs simultaneously with positive IOD, will it lead to floods in India? Jasmeet, absolutely yes. Very good. But simultaneously, if it is a positive IOD and this low pressure system is present in Eastern Indian Ocean, it will reduce the rainfall in India or reduce the impact of the positive IOD. Kamal Pal, MJO can intensify old and El Nino or La Nina. It can influence or exaggerate the impact of these ENSO cycles, yes. Yes, Kamal Pal. Then Devansh, generally region where air sinks have comparatively cold temperature. It depends, Devansh. It depends. For example, 30 degrees, the subtropical high pressure belt, you have higher temperature, but that is where the air is sinking. Why does MJO move from west to east? Owing to the rotation of the planet from west to east. That is what carries the circulation also from west to east. Okay. Pratyaksh, can we say one phase include building the pressure zone and the other phase include suppressing it? But that is not a technical terminology, Pratyaksh. You can say so, but ideally I would advise you phase of enhanced and phase of suppressed rains. Okay. And Prashant, how low pressure transfers towards high pressure in MJO? So basically, the high pressure region overall, Prashant, you will see that is dry condition, lack of rainfall, and higher temperature as well. Whereas the low pressure, due to significant amount of rainfall due to the cloud cover, there it cools down a bit. So that is where wherever it is more heated up, that will become the new center for low pressure. Okay, right. Now we move to another very important phenomena in terms of the atmospheric conditions and also for your examination, that is the jet streams. Now, jet streams. So, the understanding or the discovery of these jet streams is basically drawn back to the era prior to the Second World War, when you had a French climatologist who basically was experimenting with a weather balloon, and he observed or experienced a very fast moving air column at a greater altitude. But then, obviously, due to lack of resources and other factors, that particular research could not be carried on forward. Now, fast forward to the Second World War, when Japan attacked the Pearl Harbor in United States. United States was pulled into the Second World War. That was for the first time United States was attacked directly. Now, United States wanted to convey a lasting message to Japan. After all, how dare someone launch an attack into the United States, and that too where its army, or rather where its navy, was placed. So United States came up with a plan that we will have our bombers, that is the fighter bombers, they will carry out the bombs all the way to Japan and somehow will manage to scramble back. Many of the planes were lost in the process, but nonetheless, they wanted to show that machismo in a way. Now, these bombers, when they undertook the mission to cross the Pacific, bomb Japan, and come back, they observed or experienced something unique. While they were moving towards Japan, they observed that they experienced a significant reduction in speed. And while they were coming back from Japan into United States, they experienced that their speed of the aircraft suddenly increased. So initially they thought it was an anomaly, the weather anomaly which keeps on developing. Later on, more and more pilots observed this phenomena. They observed that if we are moving in a direction of east to west, the speed is reduced. And if they are moving in a direction of west to east, the speed is increased. Now, they reported it back to the Air Force headquarters. Now, in any country, the Air Force headquarters will have a lot of climatologists working as well, because you need to know the weather pattern, the temperature conditions, the pressure conditions, etc. So they reported it back. The climatologists, they then started studying this phenomena. To their surprise, they observed the same event even while crossing the Atlantic. That while you move from the United States to Europe, that is in a west to east direction, the planes would experience a jump in their speed. But while coming back to United States, the planes would experience a decrease in speed. That is where they came to an understanding that there must exist a very strong current of wind movement in the upper region of atmosphere, which is seriously impacting the movement of the aircrafts, increasing the speed or reducing the speed. And that is where the stream of air, or the very fast moving air column, that was known as jet streams. And that is how the name jets in general came across, because they influenced the fighter jets and their flying speed. So that is how the entire jet streams became known to us. Now, in the initial days, not much was known. It is only during the satellite era when we are able to track these jet streams as well. In the initial days, not much was known about it. So, what do we know about these jet streams? Now we know enough. Now we know about their formation as well. Still, there are many unknowns in the region of jet streams, but still, we know it much better than what we know about MJO, for example. We know our jet streams much better than that. So, here, when we talk about jet streams, they are relatively narrow bands of strong wind in the upper levels of atmosphere. Now, the winds blow from west to east, but the flow often shifts north to south. What do we mean by that? We basically mean that if this is, let's say, the planet, and here you experience the jet streams, these jet streams, they can move up, they can move down, but their general direction of motion is from west to east. Okay? Yes, Vipin, that is correct. Now, here, jet streams travel in the tropopause, the area between the troposphere and the stratosphere. Generally, the height is not fixed. The height of the jet stream, that is something which varies from around 10 kilometers or 8 kilometers in certain cases to almost up till the top of troposphere. So if you think about the land, let's say this is the surface. Here, you will find that the jet streams, they have a meandering path. That is, in certain areas, they can dip down to even a height of around 7 to 8 kilometers. And in certain areas, sometimes in certain years, they can even go as high as 15 kilometers. Now here, please don't be a stickler for this 7 and 15 or 8 to 15, that you have said 7 to 15, but in one book I have found that it is written 9 to 14. So which one should I remember? Don't remember any of them. UPSC is never going to ask you, if you are no longer in your class 8 level examination, that it will give you a fill in the blanks. That jet stream exists between dash kilometer to dash kilometer. Such kind of questions are not expected in UPSC, because even UPSC is wise enough to understand that this height is something which varies in between the various different seasons, in between various different years, and also from one region to another, this speed, this height tends to vary. If you have to imagine this movement, imagine it like a flow of river or of air in a way. We know how the river flows. We know how the river flows in the sense that it will have a definite pathway, isn't it? And generally, when we take a look at the river flow, what do you observe? You will observe that the regions which are at the side, the speed is slowest. The speed of movement increases as you go to the central portion. It is going to be the maximum at the central portion, the speed, and again it will reduce significantly as you come to the sides. Isn't it? We have observed this. We have observed that speed is maximum around the central and minimum at the sides. Okay? So here, that is what you experience even in the case of these jet streams moving. If you look at the speed on the sides, the speed can be around 100, 120 to 20 kilometer per hour. This speed on the sides can be, let's say, roughly around 80 to 100 kilometer per hour. The speed of the central portion can be as high as 400 kilometer per hour. Sometimes exceeds even 400 kilometer per hour. Now, Here, these are the strong air currents which tend to look like wavy striated rivers when seen on a jet stream map. They form when cold air and hot air meet. That is their formation. So wherever in the upper atmosphere you have a condition where the cold air meets with warm air, that in itself generates a jet stream. So how? We'll understand that, but with the help of the tricellular model of circulation, which I hope few of you have at least revised. Now here, if you take a look at the formation, you will observe that there are three areas where you have different air columns in the upper atmosphere. One is this, one is here, and another one is here. Now let's name this A, B, and C. Now at the point of A in upper atmosphere, if you analyze this, at the point of A, will there be a difference in the air temperature of this portion or this portion? Will there be a difference in air temperature? What do you think? No, it won't be. Why? Because both the winds are being driven from the tropics in both the hemisphere, so both the wind is warm. Now in this area, here and here, will there be a difference in air temperature at B? Absolutely yes. Why? Because one is coming from 60 degrees, another is coming from around equator. So obviously there will be difference. Then what about here A and here B? Will there be a difference in this area? Absolutely yes, and very strong difference, because there one is coming from the poles and the other wind that you see is coming from the tropics. So obviously there is going to be a massive difference in temperature. Now what does that create? That creates an impact in the upper altitude in terms of pressure difference. Even though you don't need to go into the depth of it, that how it is generated, what is the process and all. But nonetheless, let me give you some idea how this temperature difference leads to a pressure difference at upper altitude or upper atmosphere. Again, I'm telling you, if you don't understand it, don't worry. UPSC is never going to ask you about this logic. But those studying geography as an optional, you can pay attention here. Now here, when we talk about the volume, which air has greater volume? Colder air or warmer air? Which of them do you think has got a greater volume? Colder air or warm air? Always warm air will have a greater volume. Now, let's assume you have a region of warm air and you have a column of cold air. And you have a region of cold air. Cold air will have much lesser volume. Think about this as a situation that we have in C. Okay. Now, if I tell you that, okay, the ground surface pressure condition, low pressure, or I name this places as A, I name this place as B. Which will have low pressure, B or A? What do you think? Which will have low pressure in this case? Easy. B will be low pressure on the ground. Let's complicate it slightly. Right? Let's name this A1 and let's name this B1. Now, you have started considering the air at a particular height, the pressure at a particular height. Now, at A1 or B1, at that altitude, where do you think the pressure experience will be more? At A1 or at B1? What do you think? Beautiful. There will be greater pressure at B1 because here there is a significant height of air which is left above. Here you have a very minor portion of air which is left above. So B1, while B experiences low pressure here B1 experiences a comparative high pressure, A1 comparatively a low pressure, isn't it? Now, in between these two air columns, can we say that there is a generation of a pressure gradient force? Generation of pressure gradient force. We can say that because you have high pressure and low pressure. That thing will happen all across wherever that circulation is happening. So this will initiate a movement, a strong movement of air, because the pressure gradient force is significant. Because high gradient. Due to that, it will initiate a movement in every small area. Wherever you consider larger columns of air, it will initiate a movement. So that movement, when looked at from across, that is what we experience in the form of jet streams. That is how you have the existence or the formation of jet streams. In very simple terms, temperature difference in upper atmosphere creates a pressure difference at the upper elevation as well. That pressure difference created at upper elevation will experience a stronger movement of the wind. Why stronger movement of the wind? Lack of frictional force. So here at this altitude, you experience lack of frictional force. Now, due to lack of frictional force, what will be the speed of the wind? Speed of wind will be very high. And another concept that we had studied earlier in the module is when we talk about the speed of movement of these winds, basically, where is it or when is it that the Coriolis force acting is greater? When the speed of movement is slower or when the speed of movement is faster? When is it that the Coriolis force acting is greater? When the speed is faster. So when the speed of wind movement is faster, Coriolis force is stronger always. Whenever you have a stronger movement of wind, Coriolis force is always stronger. In the northern hemisphere, here, now you have only the pressure gradient force and the Coriolis force, right? Same is the case in southern hemisphere as well. But in the northern hemisphere, the bending is in which direction? The bending is in rightward direction, isn't it? In the northern hemisphere, the bending is in rightward direction, right? So if, let's say, an air parcel tries to move from here to here, because the cold air will be supplied from the polar region. This cold air will be supplied from the polar region, warmer air from the tropical region. So if the air wants to move from here to here in that small region, it will be moving very quickly because of lack of friction force and very high pressure gradient force. Not only will it be moving very quickly, it will be bending significantly. Because we are in upper altitude as well, significant amount of bend, there is nothing stopping the bending. That is where the motion will be due to the rightward bend. What about the southern hemisphere? In the southern hemisphere, as the winds they try to move in the upper atmosphere, they will bend to the left. The leftward bend. That is why we say jet streams move from west to east. And wherever you have that temperature difference, there you will have the jet stream in existence. So that is how you have 4 permanent jet streams as well. 2 in the northern hemisphere and 2 which are present in southern hemisphere. We'll come to it. Now, These jet streams created due to difference in temperature will be much stronger in winter, because that is when the temperature difference in the air parcel in the tropics and the pole is very high. Isn't it? We have seen even during frontogenesis and temperate cyclone that these events are more exaggerated during the winter months. Why? Because there is a greater temperature difference between them. So they are stronger in winter in the northern and the southern hemisphere, because that's when the air temperature difference that drives them tends to be the most pronounced. The actual appearance of jet streams result from complex interaction between many variables, such as the location of high pressure and low pressure systems, the cold air, the seasonal changes which are brought about, because with the change of seasons, the pressure belts also shift. Now, when the pressure belts will shift, the jet streams above them. So if these pressure belts, they tend to shift north or south, the jet stream will also be moving or accompanying that particular shift. They meander around the globe, dipping and rising in altitude and even in latitude. Sometimes they split, forming various different eddies. Eddies are small circulations. Small circulations. Okay? And even disappearing altogether or appear somewhere else. Rahul, but in diagram, wind should blow from high pressure to low pressure. Where is it, Rahul, that wind is not blowing from high pressure to low pressure? Kindly indicate. I will wait till that point of time. I cannot have a wrong image. Kindly indicate it very fast. So that is why I say the first reaction of a candidate always is that other than me, everything is correct. Be it the evaluator, be it the examiner, be it the question paper. Ask yourself once. It is always okay to be wrong. But then, Devansh, B1 has greater volume than A1. True. Then how will it have a greater pressure than A1? Here, this has got a greater volume, isn't it? It will have more air particles also. So at B1, which will exert more weight? The warmer air, because it has a lot of particles above it. Colder air is only got these many particles. How much weight will they impose? That is why B1 is always going to be high pressure. And you will have a movement from high to low. Okay. Jet streams are formed at the junction of atmospheric cell. Ananya, yes. Vipin, this difference in temperature is also due to difference in height of tropopause in various areas. That difference in temperature, in fact, it is the other way around. It creates that difference in height of tropopause at various areas. How the Earth's rotation affects jet stream, Himanshi, that is what induces the Coriolis force, isn't it? That is what induces a west to east motion. So that is all attributed to Earth's rotation. Okay. From B1 to A1 and then to the east side. See, east or west, don't get confused in this. Here you will have polar air coming in. Here you will have warmer air coming in. Warmer air at a height will have a greater pressure. B1, A1 example, remember. And the wind will be generated traditionally in this direction. But it will deviate to the right due to the Coriolis force. And because these are very high altitude winds, they move almost parallel to the latitudes. That is why they are also referred to as a separate kind of wind system, which we refer to as geostrophic winds. Okay. Anil, my dear friend, you have a question from MJO. Okay. But why MJO travel from west to east, but at equator, trade winds move the opposite? See, trade winds are driven by a very different phenomena, Anil. And that is why I showed you the real picture of the pressure zones as well. It is not as if trade winds are a continuous feature everywhere at the region of equator. When that MJO comes in, or the IOD phenomena comes in, or the Enzo cycle comes in, these trade winds in these areas, they are always disrupted. Regarding your question why they travel west to east, it is a combination of the development of conducive pressure zones, but mostly attributed to the rotation of the planet. The planet, see, planet is rotating. Understand this. And don't apply any complex calculation or phenomena. Planet is rotating. Anything which is standing on the planet, we are standing on the planet. What is our motion? What is our general motion? If somebody from other planet was to observe us, what is our general motion? It is from west to east, isn't it? That is why, be it the northern or the southern hemisphere, all the wind patterns in general you will find, including the jet streams, etc., they are moving from west to east, right? Similarly, when we have this MJO, already you have a low pressure and a competing two high pressure systems. Now, it can have a tendency to move either way. But how it develops over the region of the Western Pacific, Western of Africa, and the second stage of development comes over the Indian Ocean, because Indian Ocean is comparatively warmer. So, because it is surrounded by landmass, that is where that particular cell, imagine this, if I have to show it on map, imagine this, that here you have the low pressure created initially, then Indian Ocean, which is slightly to the east of it, that is where it provides that competing warm condition. And aided by the eastward circulation of the planet Earth, this wind system easily is able to transfer to the east. Hence, the entire setup ends up traveling from west to east. Okay? I hope that is clear. Trade winds are no competition, Anil, for the MJO. Trade winds are not even a competition for IOD. Trade winds are something which creates normal Walker circulation. They can exaggerate it during La Nina. El Nino, again, trade winds are absent. Okay. What is the temperature difference at subtropical jet stream? Okay, the difference in temperature, Jasmeet, you are talking about in this area, these two portions. If I name it 1, if I name it 2. Here again, one of the air parcel is coming from the region around 60 degrees, 60 degree north or south, and another one is coming from around 0 degrees. Obviously, this will be cold, this will be warm. So that is why a temperature difference and an induced pressure difference as well. Okay. Now we come to the pattern of movement of these jet streams. How do they end up moving? So basically, wherever you have the warm and the cold air mass, when they come in contact at the upper atmosphere, that is when they induce a kind of a difference in pressure that induces a kind of a movement. Now, here we have seen, while we were discussing about the air parcels, that in certain areas the warm air pushes north, in certain areas the cold air pushes to the south, in certain areas again the cold air pushes south, in certain areas warm air pushes north. So due to the incursion of warm air and cold air into each other's areas, that is why the jets, they develop a kind of a horizontal variation where they move across different latitudes, right? They move across various different latitudes. But they also have a height variation. They dip in certain areas and they rise in certain areas. Why? That is because the height of the cold and the warm air, that is not always going to be consistent in all parts of the globe. So the height of the warm and cold air, that is also going to vary depending upon how warm the air is or how cold the air is. So the volume will be different. So as the height of warm air and cold air vary, point of existence of jet streams also vary. So that is where you will be observing that in certain areas near the ground surface, they come at a height of around maybe 12, 13 kilometers. maybe around 7 kilometers, again maybe around 15 kilometers. So that is where they experience a variation in horizontality as well, a variation in verticality as well. So if you have to depict it in a three-dimensional manner, think about it, a jet is coming like this, going like this, then again coming like this, again going like this. So it includes both horizontal as well as vertical variations. And overall, these jet streams, observe how you will have some column or pocket of air which will diverge from here and it will start its own circulation here. Observe this is diverging here. Observe it will initiate another circulation here, right? Overall, as long as the jet streams are present, imagine it to be kind of like a river of air present in upper atmosphere. Jet stream, right? Air blockage. Means what? Means they don't allow the air from this portion to go and cross, or the air from this portion to go and cross. Imagine that there is nobody at home. You want to go out to play, or you want to get your friends in, but somebody has locked the door, right? So regardless of how much energy you have inside the house, you won't be able to go out. Regardless of how many bats or balls or the various toys your friends have, they will never be able to get inside. So that is how the jet streams, they are able to block the cold air and the warm air, and they don't allow the mixing of each other because they provide themselves a kind of a horizontal and a vertical variation. So obviously the air is unable to cross underneath. That is where the jet streams, they are able to separate the cold weather and the warm weather systems. Generally, an area, let's say, if I consider the planet, this area, let's suppose, gets very hot. What can be the condition? Cold air can come in, can cool the area. But if I have the presence of the jet stream in that region, cold air will never be able to cross the jet stream, regardless of how hot this area gets. That is why jet streams in many parts of the world also give rise to persistent heat wave conditions, including in India. In India, these jet streams are very, very important, very instrumental in the onset of monsoon. In the rise of the monsoonal rainfall that we experience in India, this is very important. We will study when we come to Indian monsoon. We can say that the Earth has primarily got 4 different jet streams, permanent jet streams. These are the subtropical jet and the polar jet in both the hemispheres, which are at the margin of the tricellular circulation, but also has got temporary jets. Okay. You also have the presence of certain temporary jets. For example, you have the Siberian jet. Just like you had permanent winds and local winds, like that. Then you have Somali jet. Then you have the tropical easterly jet. So these are temporary jets which move over a small area and come into existence only over some time of the year, right? We will take a look at the tropical easterly jet, their generation, etc., entire process in the next module as well. But Earth has got 4 permanent or primary jet stream systems. Now here, when we talk about the subtropical westerly jet system, that is the one which is in existence here, isn't it? This is the jet stream which moves over India. Right? Now here, look at this. This is a satellite image. This is your subtropical westerly jet. subtropical westerly jet. Now observe the portion to the northern part of India. There is almost a complete lack of this jet stream. Instead, you will observe that this jet stream divides itself into a northern branch, and a distinct southern branch as well. Why? Because there is a physical barrier in the form of the high altitude mountains like Himalayas, where in this portion you have many areas or many of the peaks having an average height of 7 kilometers above the ground surface. Obviously, it provides an obstruction to the jet. Jet stream is not going to be that, okay, see, I move at 7.5 kilometers. You can have your peaks till 7 kilometers. We both can manage. It is not Indian Railways. There is no compromise here. Jet stream observes a kind of an obstruction. Immediately, it divides into two. Later on, they will meet. Later on, they will meet each other. But whenever such large physical barriers come, they simply divide into two portions. Both of these also relevant for Indian monsoon when we come to it. Now, these jet streams, they can also be referred to or understood as the carrier of various different weather systems. Carrier in the sense that you can have a cloud cover in one particular portion causing rainfall in one particular area because of low pressure. If the jet stream moves through that region, it is able to carry the clouds all the way and maybe cause rainfall in the other portion as well. So, the fast-moving air currents can transport weather systems across the world, impacting temperature and precipitation. Example, winter rains in India due to western disturbance. Again, what we will study tomorrow. Western disturbance influenced by subtropical westerly jet causing winter rains in North India. Okay? Now, these jet streams, by the way, they are also changing due to the changing climatic conditions, right? Now, overall, we have already seen they play a key role in determining the weather because they usually separate colder and warmer air. Warmer air is separated, cold air is not allowed into that region, and vice versa. As a result of that, some region which is very hot, very warm, but does not have the facility of cold air coming in and moderating the conditions, that area will become more warm, more hot. It can experience even a heat wave like condition. So that can generate heat waves in certain parts. Okay. Can generate heat waves. Now, we know that global warming and climate change is upon us. Now, due to global warming and climate change, the temperature across the planet is rising. What do you think will happen to the intensity of the jet streams? Will the jet streams get stronger? Will they get weaker? In general, what do you think will happen due to global warming? Will they get stronger? Will they get weaker? Abhishek, Ananya, Pranay, Jasmeet, Amit, Yasir, Nisarg, very good. Shruti also very good. So due to climate change and global warming, the jet streams tend to get weaker. Why is it so? Because even the polar regions are warming up. So the difference in temperature between the cold air and the warm air, that is reducing. As that difference is reducing, obviously, the pressure gradient force is also getting weaker because the difference in temperature is less. So that is what is able to lower the speed of the jet stream movement. Okay? Right? So it gets weaker due to climate change. Warm air is not getting so warm, Sahil, at the same rate as the cold air is getting warmer. Cold air earlier would have a temperature of -10, -15 in certain cases. Now it has got a temperature of 2 degrees, 5 degrees Celsius, whereas warm air from earlier 30 has gone to 35 in certain cases. So it is not incredibly going at 60, 65 degrees Celsius. Okay? Now, consider the following statements. Jet streams occur in the northern hemisphere only. Only some cyclones develop an eye. The temperature inside the eye of the cyclone is nearly 10 degrees Celsius lesser than the surroundings. So we will have Raja, not exactly. See, frontal formation is observed at the ground surface, jet stream at the upper surface. Frontal formation immediately responds to any movement of warm air or cold air, and fronts cannot stop the movement of cold air from warm air, into warm air region and vice versa. Jet streams can do that, right? So it might happen that there is a creation of a condition in North America and it can have a jet stream impact all the way in Europe. So that can always happen. Same cannot happen with front. So good. A significant majority of you have given the correct answer. So here, jet streams occur in the northern hemisphere only. Incorrect. Both in the northern and southern hemisphere. So wherever you find one, it is wrong. Only some cyclones develop an eye. That is correct. That in temperate cyclones, few of the cyclones, they don't develop an eye. Few of them can develop an eye. Anyways, the two option statements that are left, in both of them, 2 is correct. 3, the temperature inside the eye of the cyclone is nearly 10 degrees Celsius lesser than the surroundings. But we know eye of the cyclone has a greater temperature. That is why you have lack of cloud cover, and that is due to latent heat of condensation. So eye of the cyclone always has got a higher temperature. So the correct answer will be C, 2 only. This is where again many of the candidates, that is why UPSC mentioned 10 degrees Celsius. Many of the candidates, when they looked at it, immediately they got that understanding that what has happened, I have studied tropical cyclone, I might have missed out whether it is 10 degree or 8 degree. That is where UPSC wants to divert your attention. If you keep your attention at the larger thing that it is conveying, you will mostly get the questions correct. You'll find this to be true in polity as well, in economics basics questions as well. It is that trend and that critical thinking that you have to develop. Once you are able to develop that, there is no stopping you, no force going to stop you in the prelims at least. Okay? Yes, Himanshi, absolutely yes. Then we come to the portion of India's climate. Easily one of the most complicated portions in the entirety of climatology across the globe. This is considered to be one of the most complex areas. That is Indian monsoon. Now, there always has been a lot of effort in order to understand this phenomena. What is this monsoon? How is this created? We Indians, we knew about this phenomena for a long time. That yes, there is certain season of the month when we experience rainfall. But it was the Arab travelers who for the first time documented it. And when the Arab travelers were coming to India, they realized that during the month of June, July, and August, that is when you have winds which blow in southwest to northeast. And they would use these winds during these months to come to Indian coastline. And they also knew that it is during the months of November and December when the wind direction would completely change and reverse. And they would use this wind to get back away from India. It would carry them to their destination. They were aware of this. Now, they used this and depicted this as Mausim, which meant seasons. And from that, the term monsoon has been derived at. Now, monsoons are very, very important for us Indians, from driving the economy to determining the kind of food habits that we have, to influencing the climatic conditions across various parts of the country. Everything is influenced by monsoon. In fact, one can even argue that in certain cases, the political might of a particular government has also been overthrown because of the impact of monsoon. Because whenever you have weak monsoonal rains, immediately the rural economy plummets. And that has an impact on the urban demand as well. And overall, the economy goes on a downfall. Right? That is where suddenly you will have the prices of certain products skyrocketing, and that can mean the end of a particular governmental setup. This has happened in our country. So that is why monsoons is very important for us. Almost around 75 to 80% of our annual rainfall is received during these 3 to 4 months of the year. That is why it is very important. That is why for UPSC as well, this is again going to be very, very important. UPSC doesn't miss a chance to ask you a question from the portion of monsoon. So in the prelims, you'll find questions for basics of monsoon, the features, distribution of rain, then factors affecting monsoon, right? Also portions of western disturbance. Then in the mains, questions from factors impacting monsoon, and then western disturbance. Earlier, that is around 15-20 years back, UPSC had a different pattern in the sense that it would have very long questions, 600-word answers that you had to write. So there UPSC used to ask questions that describe about Indian monsoon. Now you had these very thick guidebooks which were available, which did not describe it perfectly, but they would talk about the features of the monsoon endlessly for 2 to 3 pages. What people would do? People would mug it up. They would simply mix it up in water, they will drink it up, and they will vomit it in the exam hall. Obviously, better that you vomit, better marks that you get, better you are able to recall. And that continued till the ARC report which was submitted, which told them that, see, the pedigree of the candidates that we are getting as a result of these types of questions, that is obviously something that we don't want. And that is when UPSC started tweaking not only with the type of questions, but also how many words you are expected to write. Because if you are expected to write 600 words, in between, even if you write cricket commentary, many of the times that is also lost in the din of the matter. So that is why UPSC has now become very significantly changed in terms of the questions that it has been asking from this area. Nonetheless, factors influencing the monsoon, western disturbance, these are the areas which are frequented by UPSC. But first of all, here, very briefly, we will be talking about the factors which influence the climate of India. Because please understand, India is that very unique land. India is that very unique civilization, so to say, where if you move from north to south, from east to west, from dry sandy desert to even the cold deserts, from very high lofty peaks of Himalayas which are permanently covered in snow, to areas which receive maximum amount of rainfall throughout the year across the globe. From heavily forested areas to sandy beaches, we have got it all. We can purely say that we have got it all. In fact, during the 1800s, it was in geographical community, it was famously known. If you want to study the world climate, go to India and travel to various parts. That is why Gilbert Walker, when he discovered that Walker cell, and he basically came upon that discovery, immediately he wanted to come to India to observe that whether it is having an impact on India or not. So that is where India's climate is truly very unique. For many parts of the country, we experience a very distinct winter season, which is very cold, a distinct summer season, which is very hot, and spring and autumn in between. So what are the factors which end up influencing India's climate? Basically, the latitudinal extent. India lies to the north of equator. Tropic of Cancer cuts through the center of the country. So being to the north of equator means you will have a condition, and Tropic of Cancer passes through it, means on June 21st, the sun will be directly overhead the central portion of India. And again, India experiences a distinct winter as well because it is to the north of equator. So the latitudinal extent also plays a part in influencing India's climatic condition. Then you also have the influence of the Himalayan mountains. When we say the Himalayas are the true natural frontiers that we have got in the northern part of the country. Not only have they historically protected us from various invaders, from various different intrusions, but they also influence the river systems which originate through that region, thereby influencing millions of people. But more importantly, Himalayas, they act as a climate regulator for India. When you have moisture-carrying winds coming from the region of Bay of Bengal and Arabian Sea, had the Himalayas not been there, these winds would have simply moved ahead. But they don't, because the Himalayas act as a barrier. Also, during the winter season, you have very cold winds which are generated from the region of Siberia, local winds. They are generated from the region of Siberia. The presence of Himalayas does not allow the cold winds from the north to sneak in. Otherwise, the entire region of northern plains would have experienced very cold conditions, further cold conditions during the winter months. That is why we say Himalayas, they shape every aspect of our lifestyle. The crops that we grow, the water that we drink, to having our national security in many of, and historically, from the time of Kublai Khan, the great Mongol, to the time of Attila the Hun, the Huns, they were also warded off due to the presence of this formidable barrier. You have questions being asked from this portion as well. Describe the role of Himalayas. So there you have to describe the natural frontier, the defense area, everything you have to be able to describe. Okay? Now, a couple of more points and then we'll end the session. The impact on India's climate is also significantly played due to the relief features. Relief are the physiographical divisions. Nonetheless, we'll pick this up tomorrow. That is when we'll initiate the discussion from here. Tomorrow, we will study the monsoon. This is going to be very important for you guys. Okay? Regardless of how many different books that you go through, that is something which is going to create a confusion in your mind. So I would suggest all of you attend the session. Whatever the previous ones, for example, look at what are jet streams, look at what is permanent circulation of air. That is the permanent wind system. These two things you should have an idea about. Come to the session tomorrow. Once you get this monsoonal system correct, after this, whatever is left is largely very theoretical. That you can, if you want, you can finish it in 3 to 4 days. That is how theoretical portion is left. This is the last major frontier, if you think about the last major conceptual portion of geography that you have to conquer. Once this is done, you can take a sigh of relief. So see you again tomorrow. Before that, let us take a couple of questions here. Okay. And Biswajit, why desert is found on the west side of every continent? Because of the cold circulations which are present, cold oceanic circulations which are present, my dear friend. But then we don't know what are cold oceanic circulations. We don't know what are the impact created by cold oceanic circulations, isn't it? So this is a part of the UPSC previous year question. We'll come to it once we come to oceanic circulation. Then Shamil, very good. That is something that you can always improve upon. See, if you maintain an average of 7.5 to 8, there's no one touching you again in the mains exam. Neil, remind me tomorrow once. Jet stream is in tropopause and air parcel rises to the maximum of tropopause. How there is still a greater pressure difference? So jet streams, their maximum height is tropopause. It is not that they are always generated at tropopause. And the tropopause also doesn't have a fixed height. I hope we are able to imagine, Gagan, that tropopause, their height varies in between the various seasons as well. So that is how they can be generated. And depending upon the volume of the cold and the warm air, that can always have a vertical dip. Okay. Pranay, initially jet streams created because of temperature difference. It can be strengthened by less frictional force and Coriolis force. Yes, absolutely, yes. Prashant, if there were no Himalaya, UP used to receive. UP never used to receive snowfall. UP could have received snowfall in that case, yes. Mupkalvar, is the monsoon one of the reasons to invade India by Europeans? No. Spice. The climatic conditions, that is what made the growing of spices more conducive. And they wanted to get spices. Why did they want spices? Not that they wanted a food in certain way, but spices acted as preservatives. And this was the best preservative in the form of black pepper, which was available to them. That is why the Europeans, they started the entire phase of colonization across all the various tropical countries as well. Sukanya, which cyclones not form? Some of the temperate cyclones, they don't form an eye. Tropical cyclones, all of them will form an eye. Yaram Seti, what about jet stream types? So you have two types. The permanent jets that we have seen, polar jet, subtropical jet in both the hemispheres. So you have 4 of those permanent jets. And the temporary jets that I listed, that is the Siberian jet, Somali jet, tropical easterly jet. These are examples of temporary jet. When we come to this module in itself, when we read this module in detail, we will talk about it. That how, for example, tropical easterly jet is created. I hope now we understand the formation of the permanent jet. So when we come across the formation of a temporary jet, that will help us significantly. Anil, there is too much hodgepodge in Enzo, MJO, and jet streams. How to remember it in an easy way? By understanding them. There is no other way to remember them unless and until you understand what they are, why they are created. Everything is given in the PPT. Go back, look at the PPT. If that is still not clear, look at the tablet videos. Then you will be very clear. But for that, you need patience, my dear friend. Basically, South Indian area is hot, but why there is so much snowfall in Ooty? Shruti, kindly confirm. When is it that you saw snowfall happening in Ooty? Okay, and you are writing so much snowfall in Ooty. Ooty is not a place which receives snowfall, my dear friend. Ooty receives hailstorm. Ooty receives lower temperature, snowfall, and that too much snowfall you can say about Jammu Kashmir. Definitely not Ooty. Okay, look at the weather conditions throughout the year. It is available on Google. You will not find the significant snowfall. So the source of information is significantly incorrect. And then Harshita, MJO can affect the procedure of La Nina and El Nino? Yes. Devansh, how latitude of place, altitude of place, and nature of slope affect the distribution of temperature by influencing the amount of insolation received? This is again something mentioned in the earlier module about air temperature. You will find this altitude, lapse rate, that is how, and the direction of the land, depending upon it, insolation varies. That in a way changes the amount of insolation, changes the temperature experienced. Okay. Harsh, I've missed some of the last classes. What should I read and come so that? Okay, Harsh, I would suggest to you that if you have missed the previous classes, kindly look at the portion of the permanent wind systems and the portion of jet streams. These two areas get very clear about, and rest of it we will take care. Amit, I missed 12 and 13 lecture due to certain issues. Now I'm facing difficulty to pick it up. No issues. Just revise it from the recording of the videos are also available. Or if nothing, look at the topics which are covered. Go to the tablet. Tablet videos will also be very sufficient. Gagan, why do not MGO concept occur in every wind movement, leading to a toggle of high pressure and low pressure? Gagan, that is because it is around the equatorial region where you experience the doldrum-like conditions, where you don't have any significant amount of weather change which is experienced. Same can also be said about horse latitude, but in the horse latitude, you have sinking air column. So that does not allow the creation of an enhanced rainfall area, because already when you have a sinking air column, it can never lead to convective rainfall to occur. So when that does not happen, so obviously that low pressure will never get transferred into a high pressure. Okay. Okay. So that is where we'll restrict the session for today, guys. Any of the questions still not answered, don't worry, the SMEs are here, or you can write to us. We'll get back to you. So see you again tomorrow for the portion of Indian monsoon. Take care of yourself. Goodbye and have a good night. Thank you. Okay, a couple of questions I'll answer before going. Yaram Sethi, using technology or any research is going to neutralize? No. These are two large phenomena. And in chat, I asked relation between happening of IOD positive and La Nina. Generally, they don't influence, Shrikant. Let us come back tomorrow. We'll get back to it. Thank you.